Hi, everyone. Good morning. Good morning, everyone. You all are in for a treat. We have Amy Marich from Red Hat, and I'm going to let her take center stage. Have a great presentation.
Put it on short person mode. All right, so my name is Amy Marich, for those of you who don't know me. Hello? Is that better? All right. Put it on super short person mode. All right, my name is Amy Marich, for those of you who don't know me. I am the vice chair of the OpenInfra Board of Directors, and I serve on the technical committee as well as being a core on multiple OpenStack projects. I work at Red Hat as an open source evangelist, specializing in OpenStack. So what we're going to cover today is an introduction to OpenStack. I'm just going to take this off here and see how it goes. I'm also going to talk about the most common OpenStack services, the ones you most likely see in an implementation, some other services that are popular, how to get involved in the community, and then we'll have time for a Q&A. And if I go too fast, somebody raise a hand because I do talk fast. All right, so we're going to start with an introduction to OpenStack. So what exactly is OpenStack? It's an infrastructure as a service. It utilizes common APIs to control large pools of compute, storage, networking, other resources, all in one or more data centers. So you can be in one location, you can be in multiple locations. So next we're going to go into some of the most common OpenStack services. This is how the services interact. So in order to keep things easy to follow, I'm only doing some of the services. This diagram is also helpful to visualize how the projects we'll be discussing fit together in the larger picture of OpenStack. For example, the diagram shows you how Horizon provides the dashboard, which is the UI. There's also Skyline, which is another UI project. But how does it connect to Keystone, which is your identity? And then how does Keystone interact with the other ones? Now, when I talk about these projects, I tend to talk about them in the order that you would install them if you were doing it by hand, because I think it helps you to understand how the individual pieces fit together. So the first thing you need is the identity service, which provides your authentication. It provides the APIs for client authentication, service discovery, distributed multi-tenant authorization. And when we talk about Keystone, now the token may be revoked at any time, or you can also give it a timeline. And while OpenStack Identity supports token-based authentication, the intention is to support additional protocols in the future. We're continually working on this. And the main purpose is to be an integration service and not aspire to be a full-fledged identity store and management solution. Now groups. Groups are kind of optional. You don't need to use them, but they can make your life more easier. So it's a collection of users. So say you want to give a group the same permissions, the same quota, you can do it in one place with a group. Services refers to a service running in OpenStack, such as compute, which is the Nova project, object storage, which is Swift, image servers, which is Glance. And I'm going to try really, really hard not to mix my project names and my service names. So if anyone catches me doing that, let me know. And they're provided by one or more endpoints in which users can access resources. So if you were setting up your endpoints, you're going to have a public, an admin, and then a private. So you've got 3 different endpoints going. Endpoints. See how this all works together? A network accessible address where you can access a given service as a URL import. It can be configured to service requests on the three, as I mentioned, public, admin, and internal, which I called private earlier. Now, domain. Domain is a collection of projects, groups, and users that provides an administrative boundary. And you actually have to create the domain first if you're going to use domains, otherwise you kind of go to default. But say you wanted to break everything up and really keep people separate, the first thing you're going to do is make a domain and put the project and the user in that domain, and it cannot cross domains. Now, region. We mentioned that you could be multi-data center. Those are regions. And each region will have its own set of endpoints, but you can use a common keystone so that it's all using the same users and projects. The catalog is basically your list of services and endpoints. So we talked about how you get a token. So the user sends their credentials to the identity service. The identity service says, hey, I got your token. Then the user, this is all automatic so they don't see it. It then sends the request and the token to the various service. The various service goes back to identity and says, is this person really who they say they are, and do they have access to me? Identity has reported back and says, yes, this person is good to go. They can use an image. So it goes back to the user, and they can now see the images. Do I have the same one twice? No, I do not. Okay. That's not good. Hang on. User error. All right. I usually use a pointer, which is probably a better idea. All right. So in this case, our user is sending its credentials, because we're using a token, to the desired tenant. Tenant can be interchanged with project, and we're really bad about that. Keystone sends a list of the available services saying, hey, let me bring up your interface. You've got access to networking, compute, images. And the tenant receives their token. The user then determines which endpoint they're sending to, and they provide the token along with the request. So if we just installed our keystone, now we're going to install our glance, because before you can do anything, you need images. So the image management service is the component that discovers, registers, and retrieves your virtual machine images. Those can be QCOW, they can be ISOs, they can be images you saved from another VM that you created. Some of the capabilities of the image service are administrators can create base templates from which their users can start new compute instances. So if you want to make it really easy and say, I want all my developers to use this image, it's got everything I want in it, you just give them access to that. Users can choose from available images or create their own from existing servers. As I mentioned, I've got a server, I made a backup of it, and now I want to keep using that one. Snapshots can be stored in the image service so that virtual machines can be backed up quickly. All right, so we've got our authentication, and we've got images that we can use. So now we're playing with the big boy, compute. So the compute service is how you're going to provision, and also a little bit of where you're going to provision. It creates the virtual machines, the bare metal servers, which is another project called Ironic, and has limited support for system containers. There are other containers projects, Magnum, which does clusters, and Zuul, which does individual containers. So some of the compatibilities of the compute service. The creation and administration of flavors, your machine sizes. I want a teeny tiny one, I want a huge one. Management of quotas. This project only can have 5 VMs. Once they hit 5 VMs, they're done. They're going to have to contact me before they get any more. Management of security groups. Security groups also control your IPs and protocols. So I want to allow ICMP in. I want to allow SSH in. Networking, everyone's favorite subject. So the networking service, yes, it's networking connectivity. There's no other way to say it. It also provides different facets of VNI, layering, so you can have ML2, ML3, physical networking infrastructure. Some of the capabilities enables projects to create advanced virtual network topologies. So you can have multiple networks running within your OpenStack cluster with one connection out to the real world. Provides both provider and self-service networks. Depends on how complicated you want your networking to get. Provides networks, subnets, and routers as object abstractions. And it supports the security groups to block or unblock ports and traffic types. This is networking. So you can see on the compute node that we have Linux networking utilities. This is actually kind of older because we're talking about Linux bridges, which we have now taken out. But you can see how the physical network connection connects through the interface to the interface on the compute node and then sends it out to the internet. So some additional networking services, load balancing, Octavia, so much better than LB version 1. It's now its own separate project. You can actually look at logs this time, where the original you couldn't, and you were like trying to figure out, why is my load balancing not working? Well, now you can actually find out why your load balancing is or is not working. DNS, designate. So you can actually run your DNS server within OpenStack. The dashboard. There are actually 2 dashboard projects within OpenStack. Horizon, which is Django-based, and SCaLE, which is a newer one that's been getting a lot more attention lately. Rackspace is using it if you want to see it in action. So dashboard, web-based user interface to the OpenStack services, so you can look at everything. It allows for management and administration of the OpenStack services, and it's based on roles to control what a user is able to see and manage. So if I log in as an admin, I'm going to see everything that's running. I'm also going to be able to look to see what my load is, how many servers are running. But if a regular user just looks at it, they're going to be able to create a VM. They may or may not be able to do anything with networking besides look at it and maybe get a floating IP. They can look at all the different flavors that are there and the images that they can use. So this is actually a view of the Horizon dashboard, and this is an administrator view. So as you can see, I mean, I wasn't really running anything when I took the screenshot, but you have an idea of what it would show you. Block storage. So the block storage service is also known as Cinder. And I seem to have gotten rid of my animations. So the block storage service provides volumes to Nova virtual machines and Ironic for the bare metal and containers. So block storage enables the ability to add extra block level storage. So for instance, it's like adding a second hard drive. I ran out of space, I need more space, let me add another drive. It allows you to boot from volume, and it allows for backup and restoration through LVM snapshots. Now, object storage. Think S3. It's the easiest way to say it. It's object storage. So it provides highly available, distributed, and eventually consistent object block storage. So the idea is that it is highly redundant, but not everything may be updated at the exact same time. So you have an account. You have a container. Oops, I have two containers. Now in this container I have one object, and on this guy I have two. And this is just how it is served up. Data is organized in this manner of account, container, and object underneath it. Now this holds same for containers, objects where the container holds multiple. They're all unique, and they're accessed via a URL. Orchestration, love it or hate it. So Heat is the service, the project that is behind the orchestration service. And what it allows you to do is say, I would like to deploy a WordPerfect engine and consistently every time. And it says, okay, here's your server, here's your network, here's your storage, and you bring it up. And that way, everything is totally consistent. Now, orchestration can also be used in regards to auto-scaling, along with the Noki project and Watcher. So now another thing to think about when we're talking about orchestration is the networks involved can be external networks, internal networks. But the idea is that this is all consistent. So if you bring up one WordPerfect engine, it's going to be exactly the same as your next WordPerfect engine. So behind the Heat is something called a template. And each of the templates give you certain capabilities, and it changes based on the version of what you can do. And the idea is that they can be very specific, and they provide the whole lifecycle application management. All right, I've mentioned it. It's so much better when it does it like this. Ironic, bare metal. But we also have Cyborg, which is for accelerators. So if any of you are working with GPUs, you're most likely working with Cyborg. We have several deployment projects. Cola Ansible is very popular. It uses containerization. OpenStack Ansible, which uses Ansible to do LVM containers. It can also do bare metal. Sunbeam is a more recent project out of Canonical. I believe it's using charms. So getting involved. Contributions. But contributions aren't just code. Documentation, reviews, translations. We have special interest groups, which if those of you who were in the keynotes this morning heard that the scientific SIG is celebrating 10 years. We have public cloud, scientific, as I mentioned. We also have a couple working groups. The most active one and oldest one is diversity and inclusion. The working groups are actually from the board of directors, so they fall underneath the board versus just existing within the project itself. So for D&I, we also cover the Kata project, Starling X project, and Zuul projects. Any questions? Because I know I talk fast. Yes? Okay, the question was, what is one of the challenges of getting new people involved? In a nutshell. I think a lot of times people don't know where to get started. When we did the very first diversity and inclusion survey, a big thing that came back was the tooling. So we started doing Git and Gerrit workshops There is a version of that tomorrow, which will help you get your Git and your Garrett and all your user IDs going. So we can help you in that way. My suggestion when people want to get involved is to find a project that interests them. Hang out in that channel, meet the people, attend their meetings, start doing reviews. Let people get to know you and earn some trust. A lot of the projects will have easy to start tickets, bugs. Some of them are easier than others. And that's a great type of first issue to start. I also tell people documentation. If the documentation is off, I will find it. So that's another good place to start. Coming to these events, hallway track is more important than any talk you will attend. So, now, mind you, if you want to do the Get and Garrett Lunch and Learn, that is really important. But find someone, start a conversation. We will talk to you. We will answer your questions. We will be whatever you need us to be, and we'll try to get you involved. Because sometimes it's easier if you know somebody to get involved. I am mainly on Matrix, which is bridged to IRC these days. I am Spots, S-P-O-T-Z. Y'all are free to hit me up. So that is a good way. But I say reviews is a really good way, and documentation is some of the best ways to get involved. Any other questions? Yep. Okay, so the question was, how do you, let me get up there. I know they're filming. How do you move your cloud? So were you at the keynote today? Okay, so there are certain tools that are available now, especially since VMware, that will help you with your migration. They're third-party tools. We do not necessarily have anything within OpenStack itself. You also may, depending on how complicated what you want to move over, is save it, then port it up and bring it up as an image, as a new VM. May not work perfectly. You may have to recreate your networking versus using a tool, but there are ways to do it by hand as well. And there are some open source projects. I know there is Atmosphere out of VexHost, which is available via open source. I do know there are some tie-ins to their public cloud, but I'm sure it could be hacked to not have that limitation. But it is open source. Any other questions? All righty, I will give you all 5 minutes back to your morning.
Hi, everyone. Just give us about 5 minutes. We're just having some technical issues. Thank you. Hi, everyone. Good morning. And we have Dr. Link here. He actually did his PhD at the University of Nebraska, Omaha, in DEI and open source projects. So you guys are in for a treat. His talk today is on building and supporting open source communities through metrics, reviewing open infra community metrics. So it's going to be great. Nevertheless, Dr. Link, go ahead.
Thank you so much for having me. I appreciate being here with you all. Is the microphone okay? Can you hear me well? Excellent. Thank you so much. I want to start with one idea. If nothing else that you take away from this presentation, it is that when we have a community, an open source project, what is happening today is required for any future thriving and success of the technology. If we have a project that does not have a community, that is stale, then there is no chance it is going to be abandoned. So when we are looking at open source communities, we want to look at how are they set up today, how are they doing today, to anticipate are there any challenges that we might be facing in the future. I already got a great introduction, so thank you, I'll skip this. And I am curious what you all are interested in, because I have flexibility. I can talk about this topic all day long and every day, and if you want to talk more afterwards, I'm happy to chat in the hallway. What I have prepared is to talk about why we need open source communities, to motivate why we are looking at project health, community metrics, why we want to help these communities succeed and use metrics. The second topic is the metrics themselves. There's a lot of work that is being done on metrics for open source communities, and I have some prepared for you today. Also examples of how they have been used. Then third is how to overcome technical and organizational challenges for adopting metrics. There's certain hoops that we need to jump through to get metrics into any community. And then we also can explore the OpenInfra's community metrics. So by show of hand, who is, like, you can raise your hand twice, okay? Let's keep it interesting. For the first topic, who is interested in that? All right. Who's interested in the second topic? All right. Who's interested in the third topic? And the fourth topic? Okay. About equal. So I'll pace it through to hit on all of them so everyone gets what they came for. Why we need open source communities more than ever. We have, when we look at our technology stacks and organizations, this number, 94%, surprises me because I think it should be 100%, and the 6% don't know they're using open source projects. And when we hear stories of Heartbleed, Struts Equifax, Log4j, Easy Utils, does that ring any bells? Does that get you kind of like, ooh, this is the darker side of using open source, where companies get scared? They're like, when there's a vulnerability in our software stack, how is that going to affect us? In the case of our SolarWinds, we know from reports that it took companies on average about 11% of their annual revenue to fix the software supply chain issues they ran into. And with open source, if we take open source, right now we are seeing an uptick in malicious packages being published. The cost to our software supply chains is in the billions already, and it's only expected to grow. And Gartner says companies by this year can expect about a 45% chance to have been hit by a software supply chain attack, which, if we are looking at open source, is not that, well, it's kind of getting us at surprise, but we can see the health of the open source communities really matters. And we see that only about 10% of open source components are being used. So 90% are being produced, created, without finding traction. And then of the open source projects that are published, only about 15% or so have an active development behind it, community behind it. And so we're going back to this idea, how are we supposed to fix the software supply chain issues that we are seeing? The answer that I have is we need to go back to the communities that are creating the open source software. And for that, we can use metrics to see how they are doing today, to keep tabs on them, to see early warning signs when the communities are struggling. So let's talk about metrics. I want to acknowledge that there are open source projects that don't require a community. Open source just means there is a license that the open source initiative has approved to be open source based on their criteria. The Mozilla Foundation did great service by saying there are many types of open source projects, like companies just releasing their source code as open source. Great. There's no community around it, and that's okay. But there are communities, and they all look very different. And so when we look at metrics, that becomes really challenging. I work with Biturgia, a company that has been doing this way longer than I have thought about this. And we are official metrics partner of the OpenInfra Foundation, which we are very happy to support with metrics. So what I'm sharing with you comes from that experience. And then in 2017, we started the Chaos Project, a community around metrics for open source projects. So this is my invitation to you. If you are interested in going deep on open source metrics, join us in the Chaos community. We have about 80 metrics defined and published. We have packaged them in metric models for specific use cases. And since last year, we started writing guides. So for someone who just wants to get started and needs a little bit more guidance, those guides are really there. Chaos stands for Community Health Analytics for open source software. And we have created the community for many different stakeholders. I'll jump a little bit ahead to focus more on what we are doing in the project. When we started Chaos, we wanted to have a happy symbiosis between defining the metrics on one side and the open source software that we are creating to actually produce the metrics and learn both ways. So from the definition, we create the software. From the software, we improve the definitions. Over the years, I'm giving you an introduction to the Chaos project. So if you're interested in joining, you have a layout of the landscape, what it looks like. And so when you jump into looking at the metrics and models that we've produced, you have an idea of like the background of it. What we've started doing is we've created working groups around specific topics, around risk, diversity, equity, inclusion, common metrics, like number of commits that doesn't really fall anywhere, but everyone is interested in it. And then the metric models. Today, we have metrics working groups that are defining metrics, creating those models. We also have context working groups, and those are really the more interesting ones where we're talking about specific topics around what OSPOs need, what, if we want to do science and research with metrics, what we need for that. The university academic working group, and Stephanie's here, who is a maintainer of that working group. And then since last year, we just added 2 new metric working groups. One is on the United Nations Sustainable Development Goals and how we can bring metrics in that regard to open source. And the last one, the funding impact measurement, we just launched last month, is when you have funding agencies that are supporting open source projects, how can they report on the success of that? And then we have operations working groups that keep us going. And we started local chapters in Africa, Asia Pacific, Latin America, and Eastern Europe, so that the community has really grown global. There's a lot of work that we are doing. Here's a list of the metric models that we have right now. And like, how do we, if you want to understand the safety from an open source project perspective, what are the metrics there, or funding perspective, or diversity, equity, inclusion, event badging. And then these are the guides, the practitioner guides. Contributor sustainability, organizational participation, responsiveness, security. So if you're interested in those topics, we have written how to get started looking at that in an open source project, and what metrics to look at and how to interpret the metrics, really walking through step by step on how to do this. I have a feeling you're more interested in real world examples rather than the theory. So let's get down into the nuts and bolts of how this looks when it's applied. Let's say we have a global and inclusive community, and we want to show that we are successful in overcoming all of those hurdles in doing that. An example that I found is with the WordPress community, when they reported on all of the events that they're doing and all the local translations and the local events and how many meetups and how many countries, how many people are involved. Here are some examples of metrics that can be used to tell this story. Let's say we have a community where it's really about newcomers, new contributors, and their contributions. And we want to make an argument to reinvest in this. I have an example here from Mautic. This is their stats on new contributors over time. And you see there is a peak. Also, when we look at the contributions, it peaks as well. And then it plateaus off. And when we look at the report that the community manager wrote, it was that, you know, we've been busy putting in all of the foundational work to bring new people in, so that here this uptick at the end there was possible. There needed to be a reinvestment in the community. And by showing, hey, we've had this higher level and now we are at a lower level, help this community manager secure the support from management to invest back into the community and revitalize it. Ecosystem growth, how can we show this? An example I have here from the Cloud Native Computing Foundation in their annual report. One of the graphs that we see every year is the growing number of contributors and then members. This is the latest report that I found, has plateaued, but still more and more people are coming into the ecosystem. Organizational diversity is another topic that is very often discussed, because if we have a project that looks really healthy, there are lots of people, but all of them are employed by the same company, then we have the elephant factor of one. The elephant in the room is that if that one company decides this technology is no longer important, then all of the contributors will leave. And so in the case of Drupal, they have really invested a lot into building that ecosystem of companies coming in. And I really wish that Dries would update these numbers. They're starting to get dated, but it's been really interesting to see how the number of organizations is stable, even though here at the beginning of the pandemic, the number of contributors started to go down. The number of companies behind those contributors stayed stable. And if we look at how Drupal is doing today and the announcements with their new platform, it's been just amazing to watch. Event impact, this one is a really, really good one. When we have open source communities, one of the things that is important is the personal connection that the members form. And it helps to grease the wheel and get people working together more smoothly. What the Mozilla Foundation did here in this report is they colored in. If you're looking at this chart, there are the yellow dots and the red dots. And where every contributor is one dot, and they're connected to a project like Firefox or Thunderbird. And the red dots are those that attended events. And where do these dots cluster? In the middle. So the people that went to events are more connected in the ecosystem, have more touch points with other contributors, with projects, and are more engaged. So the importance of events really is striking from this analysis. I have about 10 minutes, 9 minutes left. So I know this will be a very fast overview so that we can get to the insights from the OpenInfra metrics. So how do we overcome technical and organizational challenges for adopting metrics? I'll just give this as a primer, and we can talk in more depth anytime afterwards. Organizational challenges, this is people pushing back, saying, no, we don't want to be measured, we don't want this. And also, how do we make this useful? I've seen communities that say, we need metrics, and then you ask them, yes, for what? And they don't know. They just think they need to do metrics. So one of the first things to do is, how do we use the metrics once we have them? Because that will determine what metrics we actually need to look at and the data we need to collect. And there's several concerns around the personal identifiable information, which I'll avoid the topic beyond mentioning that it is here today. The technical challenge is for those who want to actually start doing the metrics. Where's the data? We need to identify where the data is. But more so than identifying where the data is where the community is active. Because if we are focusing only on GitHub, because we say our project is on GitHub, we are excluding all of the communication that is happening in forums, on mailing lists, in Slack and IRC, and there's a lot more that goes into creating a healthy community than what actually is represented in the Git log and on issues. So we need to think about where the community is. The data part, I think of in 3 terms: raw data, enriched data, and useful data. And so let's talk about raw data. This is almost the easiest step. It's pretty easy to write a query to GitHub, get the data, or mine an archive. Enriching the data, this is where, especially when we have several different places, bringing that together, standardizing it, making it useful where we can integrate the data. This is where the challenge really becomes fun and interesting. Managing identities. Has anyone ever used more than one email address? Or used different usernames? I see some people here. So there are several challenges around knowing the contributors and identifying them in the data set. And then finally, we want to calculate metrics. The raw data may give us when an issue was open and closed, but we might be interested in how long it actually took, the lead time. And so that may be a calculation we can do to get to the insights we want. And finally, we need to ask ourselves, what is the useful data? This goes back to the organizational challenges of what goals are we trying to support with having this metrics. There are several technical solutions. I am working mostly with Grimoire Lab. In Chaos, we also have Augur. In other communities, we have Apache Kibble and the CNCF Dev Analytics that I hear referenced quite a bit. There used to be StackAlytics, which I've heard is kind of not maintained anymore, but it existed. Or is it still around? StackAlytics is still around, okay. All right, thank you. StackAlytics.io if you want to get it, otherwise you get outdated information. All right, let's explore some OpenInfra community metrics. And as background, OpenInfra and Bitergia are partnered. If you look at the slides later, you can read some background on why we did this. If you're interested in exploring the data yourself, you can go to these links and go to the dashboards. The data is all public and available. So the OpenInfra communities are really transparent, which I really appreciate. And let's take a look at an example. So looking at change requests and how that is been managed in the Starling X community. Over the last 7 years, so pretty much since the beginning of time for Starling X, or at least for the data that we have, the time to merge, this is Garrett data, so it's been about 4 days on average across the time period. If we look at the number of contributions that are being made, we see that it's been mostly stable. There's a period where there's a dip that I'll talk about here in a second. And we see from the change of color that the activity has shifted from mailing lists to other, mailing lists have become less important to other areas. Now we overlaid this information with a graph that looks at the review efficiency index. This one, the review efficiency index is calculated as opened versus closed. So we're looking at the ratio of the community getting more into their pipeline and working it down. And what we see here, if we look at this dip that happens to overlap with the pandemic, we can all venture to guess what happened during the pandemic to the contributors. We see the number of contributions went down and a lot of spikes up and down in the review efficiency index. So a lot of volatility, whereas after the pandemic, it smoothed out. So the community is more stable, more consistent in resolving those change requests. I'll give you another example that I found really interesting. Looking at organizational diversity, the Kata containers community had a very deliberate effort to diversify the community in terms of organizations. So in this graph, I've excluded the founding organizations to see the steady increase of other organizations that are joining. And the number of colors, the more we go to today's time, is becoming more colorful. So there's more organizations that are joining. So this is two flavors of things that we can see in the data. There's a lot more that we can look at, and I invite you to find me at any time or go explore the dashboards yourself. I want to close with some lessons learned for anyone that wants to apply community metrics to their own community. I say start using metrics. Start with something that is easy to get. Once you have some metrics and some answered questions, more questions will come. But if you don't start and take that first step and get off zero, then you never embark on this journey. The metrics that you do have, consider the context of the community. Metrics often are a tool to tell effective stories. And if you're just looking at metrics without understanding the context of the community, you might miss the story behind it. So I often encourage, know the community, talk to the people who know what is actually happening and how the data that is shown in the metrics, where that comes from, what happened. With that, thank you so much for being here, and I hope you have a wonderful rest of your OpenInfra days and SCaLE. We don't have time for questions, but I'm happy to hang out in the hallway and be available. I got to visit Vermont.
Thank you. Hey everyone, give us about 2 or 3 minutes. We're gonna get it set up. Might be like 5, but yeah. Hi, everyone. Please take a seat. It's time. Okay. So, good afternoon, everyone. Today, we have Mr. James Blair, hailing from the great state of North Carolina. Go Wolfpacks. And he's going to be discussing project gating with Zuul. Not Joule, but Zuul. So I'll let you take it away, Jim.
Hi, thank you. Yes, I'm James Blair. I'm the original author of Zuul and one of the current maintainers and the current project lead. And I started a company called Migrating, which focuses on helping companies achieve success with Zuul. So I'm here to sort of talk about Zuul, what project gating is, and how we achieve it. Zuul was originally developed for the OpenStack project. OpenStack was a new project at the time. It was composed of a lot of different sub-projects that all needed to be tested together, and there was effectively no tool out there that could achieve the kind of testing that we needed to do at the time. So that's why we created Zuul. It's since grown and used by a number of other open source projects, as well as a number of companies internally. So why would you want to use Zuul? Zuul is entirely Git-driven. So unlike a lot of other CI or CD systems out there, all of its configuration is encoded in Git repositories, which means that the configuration of Zuul itself can go through code review, it can be automated, it can be validated, and it can be audited. Zuul gives a lot of, lets you do centralized or decentralized control. It implements this idea of project gating. It has a concept of speculative execution. It allows cross-project collaboration, and finally is very scalable. And I'm going to actually talk about each of these things in detail. So I talked a little bit about the benefits of being Git-driven already, but in addition to this idea of being able to review and audit configuration changes to your CI or CD system, we actually have the idea that you can write changes to your software code, as well as changes to the infrastructure that deploy that code, and those can be tested together, they can be committed together, and they can be deployed together. Zuul is actually really good at blurring the line between software development and software deployment. Zuul has a control model that you can sort of dial it in to exactly where you need it, whether that's fully centralized control, where let's say you have a central CI team that is responsible for ensuring that all of your software developers are following the same practices and are building things the same way, and perhaps they have some compliance requirements that they're tasked with meeting, that sort of thing. With Zuul, you can define your CI and CD system configuration centrally and sort of enforce that on the developers using the system. Or you can let the developers do whatever it is they want or need to do. You can give them full local control inside of their own repositories for what the test jobs do, what the deployment jobs do, things like that. Or you can use any mixture between these two. So we actually see a lot of folks find a spot in the middle where they're for example, in OpenStack, there are a bunch of jobs that every OpenStack project is required or expected to run, and those are defined centrally. And then projects build upon those jobs with their own needs and add to that. So in terms of how Zuul approaches its testing, there's I think 3 ways to see the world of CI systems that are out there. The first CI systems that were developed, they were effectively testing the past. In fact, the idea of continuous integration was that you would merge a change to your code review system, probably CVS or Subversion at the time, and then the continuous integration system would build your project and then tell you whether or not it worked. Is the build failing? Is the build passing? That sort of thing. That's all testing the past. That's testing a change after it's actually been pushed to a code repository. After that, we started to see CI systems that test the present. So, for example, you might open a pull request in a system, and a CI system might test that pull request as the developer wrote it and say, this pull request passes or fails the unit tests. This is obviously an improvement upon testing code that's already merged. You're testing code that hasn't merged yet, but there's still something missing. And what Zuul does is it tests the future. It tests code as it is going to merge into a repository. So in other words, it's all about predicting the future state of not just one code repository, but multiple code repositories. And so there's this idea of not just testing the change that the developer wrote, there's also, we're going to take that change, we're going to, in a test environment, merge that into the repository exactly as it will merge later on. And if there are any other repositories involved in this system, we'll do the same thing and test all of that together. And we're going to do all of this before any code merges into a repo. This leads into the concept of gating. And what project gating is it's testing every change that is proposed before it is merged into a repository. So if we take this idea of gating, which applies to potentially one change in one repository, and we add another repository to it, we call that co-gating. So that's changes to a set of repositories that are going to merge monotonically such that every change is tested with the current state of all the other related repositories before they merge. So now we've got the idea of 2 different Git repositories that are related to each other. We're going to test all of their changes together to make sure that they don't break each other. We've extended this idea once more to a concept that we call parallel co-gating, and that's the idea that as you're testing these different changes to different repositories, we can actually run those tests in parallel. And this is where we get into the idea of speculative execution. We're going to say that we're going to test a change to one repository, and at the same time we're doing that, we're going to test a change that builds on that to a second repository. We're going to run those tests in parallel, and that's going to speed up the system. So I'm kind of a visual learner, so I've got this diagram here on the screen of what I mean by speculative execution. So let's imagine that we have, honestly, it doesn't matter whether we're talking about one Git repository or more than one at the moment, but let's imagine that we have a series of changes to some number of Git repositories, right? And we've already merged some of them, right? So the first 2 changes here on the screen have already merged. But we've still got a number of changes that are still in testing, right? So what we need to do when we test change number 3 is that we make sure that we check it out onto the Git repository on top of changes 1 and 2. That should be pretty easy because they've already merged, but just in case we're dealing with an old state, we still need to make sure that's happening. We merged change number 3 into our test repository. We merged change number 4, then we merged change number 5, right? So we're, as all of these changes are stacked on top of each other, we merge them all into the system, and then we start tests for them. And we start all of those tests in parallel. We start tests for change number 3 We start tests for change number 4 and change number 3. We start tests for change number 5 and 4 and 3, right? And so we've got these tests all running in parallel. And then let's say the tests for change number 4 fail. At that point, we know that change number 4 is not going to merge into the Git repository, at least not in the scenario that we've been predicting, right? Since change number 4 is failing its tests, it can't possibly merge at this point. So what we do is we move it out of our little virtual queue. We keep the tests running for change number 3 because it's not affected. We keep the tests running for change number 4 because why not? We've already started them. Maybe we can give some extra feedback to developers. And then we restart the tests again for change number 5, and with the assumption that change number 4 is not going to merge. So test number 5 is being run with change number 3 and change number 5, but not change number 4. So we sort of moved it out of the virtual serialized queue right now while we find out what's going on with change number 4. And that's how Zuul performs its speculative execution. That's how it performs the gating process on all of these changes. So if we take this idea and we start thinking about more than one Git repository, right? That same example could have been a couple of changes that we merged to a library that's followed by a change to a web front end for the application. And then maybe that's followed by an infrastructure deployment change, and that's followed by something else. Zuul keeps track of all of these relationships, even if they're across different Git repositories, and understands the dependency relationship between them and honors that as it starts building this speculative execution environment for each of these tests. One of the ways that it does that is with an explicit depends on footer in a commit message. So imagine that you're writing a Git commit for one project. You commit that change, you push it up for code review. Then you're writing a change to a second project that depends on the change that you just wrote. What you can do is you can add this depends on footer to the bottom of your Git commit and say, this commit depends on this other change that I just wrote. And the way that Zuul expects this depends on footer to be formatted is as a URL. So this is all very self-documenting. You can be looking at the Git commit history and say, oh, well, this commit depends on a change to some other repository. Here's the link to that change. And because it's a URL, it could be anything that Zuul knows about. It could be a link to a change in Gerrit or a pull request in GitHub or something like that. So you can build up these sort of networks of changes in speculative systems. So you can have an infrastructure change that deploys your web front-end change that then that front-end change might be expecting a new API that's implemented by an underlying library. And so you can actually build up all of these, this network of changes that depend on each other. Zuul will test them all together, and you can do all of this before any of these changes merge into their code review repositories. And this is really the thing that we developed with Zuul that helped accelerate OpenStack's development. Because if you think about OpenStack, it's a bunch of different repositories that all depend on, they all relate to each other. They're all making changes to each other that depend on each other. And so that's exactly the sort of thing that we needed to accomplish with Zuul. And so that's why we built the speculative execution engine the way that we did. Now, we've talked about changes between different code review, changes between different projects. Those projects could be in different code review systems. So Zuul originally started with only the ability to talk to Gerrit, because Gerrit is the code review system that OpenStack uses for development. But as we've grown since then, we've added support for other code review systems. So we support Gerrit, GitHub, GitLab, and Pagure at the moment. And Zuul lets you express dependencies between changes in all of these systems at the same time. And this has actually been really useful for some of the people that I work with who have, let's say, they deal with open source repositories on GitHub, but perhaps internally they have a GitLab system and for their code hosting. They might actually have a GitLab system and a Gerrit because, hey, if you're running one code review system internally, why not run two? So that's surprisingly common. And Zuul doesn't care. Zuul will let you express dependencies between all of these systems. And if you tell yourself that you're doing a migration from GitLab to Gerrit, Zuul will help you do that because you can just move these repositories around. And then, as code review systems come and go and projects move around, you don't actually have to change your CI system or the way that you do these builds. You also don't need a monorepo. A lot of people start looking at a monorepo because they're looking at their system and they're saying, hey, I've got a bunch of different components and they're all always changing, but they're not changing in lockstep. How do I deal with the fact that these people over here are changing something and I still have to integrate it with the larger project that I'm building? And for a lot of people, the answer to that is, well, if you put it all in a monorepo, then that monorepo becomes essentially the mechanism for saying these are the ticks from one tick to the next as our system goes through time. That is one way of solving the problem, but it's a pretty drastic one, and you don't need to do that if you use Zuul. Because Zuul is all about bringing multiple projects together and then testing them together as a unit, effectively the tick of your system becomes each of, if we go back to this slide here, these are your ticks. Every time Zuul merges one of these changes, that's your entire system advancing one commit, even if it's different commits across different repositories. So that's kind of Zuul's answer to the problem that presents people and encourages people to end up with a monorepo. So if you're going to avoid a monorepo, you still have the problem of combination. How do you actually get all of these different repositories working together? And there's a couple of different methods that people use. One is library relationships. This is something that frequently shows up in OpenStack. A lot of OpenStack components just have library relationships with other components. And so whenever Zuul is doing this integration, it's pulling in the other components as libraries and then advancing them as necessary to deal with the proposed commits. There's network, using the network as a combination method. So this is the idea behind microservices. You might have different components just talking to each other over the network. Again, this shows up in OpenStack, shows up in other systems like Kubernetes, or submodules. That's a little tricky. Submodules are kind of a here be dragons situation in Git repositories. They solve a lot of problems and they bring a lot of new problems with them, but they are a valid combination method for bringing projects together, and they are something that Zuul can deal with. And in fact, I think if you use Zuul with Gerrit, that actually gives you possibly the only way that you can really have a functioning gating system with submodules, because it is very complicated to get them working otherwise. Zuul supports linear dependencies. So we've talked a lot about linear dependencies, and all of the examples that I've put up so far have been linear dependencies. That is, one dependency has a direct relationship on the next, and that's a one-way relationship. And the reason for that is because Zuul was originally written for OpenStack, where we always wanted to be able to update the entirety of OpenStack by moving one commit at a time and one component at a time. So the idea is you would never have to upgrade all of OpenStack at once. You could actually deploy every single commit across all of the OpenStack repositories one at a time. So that was our original design. But then we started seeing Zuul used by other users, folks in the embedded space or automotive companies. And they said to us, actually, we update the entire car at the same time. We don't have the need to update one part of the car and then another part of the car and continuously deploy it. Instead, we want to just update all of the firmware at the same time. And so we added circular dependency support to Zuul. And this is where you can express a dependency from project A to B, and you can express a dependency from project B to A. Zuul will test those changes. Again, it'll test them together, but instead of serializing them, it'll treat them as a unit. And so it expects them both to merge or neither of them to merge. Once again, if you're using Gerrit with Zuul, this is actually automatic. This is a feature that's built into Gerrit called submit whole topic, where you can have a bunch of changes across a bunch of different code repositories, and Gerrit will sort of submit them or merge them all atomically. So how does Zuul actually perform its tests? It uses test resources that come from a number of different places. Ideally, these test resources are all ephemeral. That lets us get repeatability in our builds. Lets us know that every build that we have starts with a clean slate. And there's a number of places that we can get these test resources from. We can get cloud virtual machines from OpenStack clouds, AWS, Google, Azure, IBM Public Cloud. All of these systems can be used with Zuul. You can get pods from Kubernetes or OpenShift, or if you have your own hardware, then you can define static nodes where Zuul just allocates an existing piece of static hardware, runs a test on it, and then puts it back into the pool. Zuul supports multi-node jobs. This is another thing that we needed to do for OpenStack that most other systems didn't handle at the time. So you can have a job in Zuul that gets more than one node from the cloud provider, and you can orchestrate different actions to happen on those different nodes. So, for example, you might have a node that is going to act as an OpenStack compute node, and a node that is going to act as an OpenStack scheduler or something like that. Then you can execute different tasks on those different nodes in Zuul. And the way we accomplish that is with Ansible playbooks. Ansible is, I'm sure you know, an orchestration system that is like Zuul, also an open source project. And all of Zuul's jobs are implemented as Ansible playbooks. So if you define a Zuul job that requests, say, those two nodes from node pool, the controller node and the compute node, then you might just write a playbook that says, on the controller node, set up the controller, and on the compute node, run the compute engine. So we're getting pretty close to time, so I did have some examples here, but I'm going to skip over them a little bit. And I don't know if we have any more time for questions or not. Probably not. So I will just be outside if anybody has any questions. Here are some links. You can learn more about Zuul at zuul-ci.org or more about my work at acmegating.com. All right, thank you.
Hi, everyone. just give us about 5 minutes. We have another speaker that's about to speak, and I know it's going to be awesome, so give him 5 minutes to set up. Thank you. Hi, everyone. Good afternoon. Today we have Mr. Olaf Wagner, and his talk is going to be on testing software-defined storage on multiple architectures in OpenStack environment. So, take it away.
All right, hey y'all, what's going on? I'm Olaf, as she just mentioned, and yeah, it should be readily apparent by now that I'm here to talk to you today about software-defined storage on multiple architectures. Just a level set up front. This is certainly not a technical deep dive, but what I'm going to be doing is essentially be sharing a use case scenario, namely how we use OpenStack in the Poughkeepsie lab in IBM Storage. In retrospect, choosing software-defined storage as a term to use in my presentation title was perhaps a bit vague. We're clearly not testing the entire concept of software-defined storage, but rather a particular implementation of it. The concept itself has been popularized for at least the past decade or more through following similar trends such as software-defined networks and software-defined data centers. Yeah, anyway, and all the while, whoever authored the Wikipedia article on software-defined storage, they may consider the label to simply be a marketing term, but clearly I would position, I would claim that there's a clear difference between the way, say, the file that represents my slide deck is saved on my laptop and how it would be stored in a high-performance computing environment, or at least you would hope there would be. One of the more recent and certainly more popular technologies to implement software-defined storage is, of course, Ceph, for which there are at least two other talks at SCaLE 22 before it's all over, but there are certainly others. I don't know why that's blue because it shows up white. Maybe you can read it. But this is certainly no exhaustive list, but working backwards towards me through time, roughly you have other technologies like Hadoop and Gluster, but working your way all the way back to what is perhaps the granddaddy of them all is the subject of my specific use case. That is because we are using OpenStack to test the storage tech formerly known as GPFS, which stands for General Parallel File System, but these days it's called StorageScale. I'll be using GPFS and StorageScale interchangeably throughout this talk. You may even hear me call it Spectrum Scale, which is what it was named up until 2 or 3 years ago. why the name change, you ask? Well, it's funny. As fate would have it, there's a local company that sued IBM for the rights to use GPFS as an abbreviation, and they won. So that is a complete lie. Although I was just making sure you're paying attention, but this company does exist, and they're right down the road, 8 miles away. You can check them out. I'm sure they have quality products. Anyway, what do we need to virtualize and simulate a GPFS cluster in OpenStack? Well, in revising my talk, I went through and I actually ripped out this diagram in this section because, well, one, there are more than one way to implement a GPFS cluster. There are quite a few, and to try to handle all that in a talk, what could be its own talk. We can simply suffice it to say that we just need some X number of VMs that are running the GPFS software, and it turns out OpenStack can do that all day long, every day. And number 3, we're not really here to talk about the specifics of storage scale. We want to talk about OpenStack. So yes, in addition to these cluster nodes that we need to virtualize to recreate a GPFS cluster, we'll also need some attached storage, which we will simulate with cinder volumes. And then while a GPFS cluster can simply use a base install would use just one network to allow for any combination of install options that a user could come up with, we actually need 3 networks. In addition to the public one, a daemon network and a SES network. And as for that attached storage, we'll need to make sure that every VM in our cluster is attached to every single other volume. Luckily for us, multi-attached cinder volumes have been around since the train release, if memory serves, of OpenStack. So without that, this exercise would be quite an exercise in fruition, or not in fruition, and you know what I'm trying to say. It wouldn't work. So in the Poughkeepsie lab in IBM storage, the OpenStack environment that was set up was named Frost, and it was set up as a dog food effort. That is to say that they were going to, that it uses GPFS as its storage backend. So not only are we going to test GPF cluster storage, we're going to use it on the backend to physically provide those volumes. So this required, up until this point, there was no GPFS driver in the OpenStack project, so one had to be written. It didn't implement all the functionality that most Cinder drivers have. It was some of the backup functionality is failing. IBM, no big deal, because IBM no longer supports the use of this driver in any of their current releases of Spectrum Scale, Storage Scale, whatever it's called. But it still works. As in an exercise last year, I had to prove to a customer who has a legacy support contract that they're still paying for, saying that IBM would support the GPFS driver. I had to prove to them that when they made their upgrade to RoHS P17.1, that it would not break their storage. Anyway, I digress. Excuse me. Back to the Frost environment. So each compute or OpenStack compute host in the environment, they are represented in the middle of that diagram there where it says sample node. Each one of those compute nodes, in addition to running Nova and whatever networking processes that need to happen for that, for a normal OpenStack compute node, it is also running the GPFS cluster software. As a result, so each node has a total of 6 Ethernet connections, two 10 gigabit connections each for the GPFS public and the OpenStack provider networks. You see those represented by what look like to me light blue lines from up here. I don't know what they look like back there. Not pictured are the single Ethernet external network connection, as well as the baseboard management controller for those nodes. Let's not forget, each node also has 2 fiber channel connections that give access to the SAN fabric, where all the storage actually happens. In addition to the complement of OpenStack controller and compute nodes, we set up an infrastructure server, not represented here. We just have to think of it in our minds. So outside of all the OpenStack services, there's a extra node we're calling our infrastructure server. It runs the GUI for said GPFS cluster. And since that GUI is utilizing and taking up that web server, all the Red Hat and SUSE repos that are offered up by the server are using FTP. Also, daily builds of the GPFS software that we're testing are copied over and provided by this FTP server. And this, the last thing this infrastructure server is doing is hosting our first set of Python scripts that enable user empowerment, and that's dubbed the Stack project. For our case, Stack project is a way of automating all the steps needed for adding a new user, which most of the time in OpenStack is just adding a user. But yes, of course, a new user would need a user account. But in our case, we're providing every user with a project. We're also providing every project with 3 private virtual networks that are not shared. Each user gets their own. The ones that we mentioned earlier would be needed to replicate a GPFS cluster. We're also setting up a virtual router to handle traffic from the external network to what a cluster node would consider its public network. And then finally, we are setting up a VM for each user to use that we call their management host, that they use as their Bastion node. So here is the OLAF example. So the little box closest to me between the blue and the orange networks is the router that's handling traffic between the external network and the green public network. The lowest box is the said management host, where the user is using for Bastion as a Bastion. And then on the right we have the top 3 are cluster nodes that are running GPFS, and then the one guy at the bottom is just hanging out a VM that's not associated with anything. He's probably I used him to make an image update or something. All right, back on this management node. This VM, the reason a user would want to log into it as a Bastion is because we've also uploaded our second tool to them, and it is called, we call it the SCaLE cluster tool. It makes heavy use of this guy right here, which is what the cloud team and Spectrum SCaLE have published on IBM's public GitHub account, which is called IBM. The name of this particular repo you can read yourself, IBM Spectrum SCaLE installed infra. So they have written a slew load of Ansible playbooks that go ahead and take care of most all of the steps you would need for setting up a GPFS cluster. Not all of them, because what we do is take all of these Ansible playbooks, we tweak a few of them because we found some errors, add a couple of our own, throw in some more Python in there, and wrap that all up and publish that to the user's management host. Again, most of the legwork for the Spectrum SCaLE cluster is done by these guys. Gotta make sure I give them credit where it's due. So when a user logs into their management host and calls this SCaLE cluster tool, the Python part of it is what's going to handle all the issuing of OpenStack resources. So first it'll check quota, then it'll make sure that the user doesn't already have in this cluster space, doesn't already have existing resources. If it does, it deletes them. Once it's got a clean slate, it deploys 2 heat stacks, one heat stack for instances, a second one for all the volumes, connects them all together in every iteration possible, and then prepares it for the Ansible playbooks to take over and start their implementation of whatever the user has defined ahead of time as the different configuration they want in their spectrum scale cluster. So yeah, prior to running the tool, the user would have had to create that config file. User specifies how many nodes, as in how many VMs they want this cluster to have, the number of disks, the size of the disks, lots of different scale things that they can specify. If this cluster is supposed to go ahead and create a file system, have it mounted, which operating system they want on these nodes. We support several different flavors of Ubuntu, Red Hat, of course Red Hat SUSE, Red Hat 7, 8, and 9, and then which node architecture they want these nodes, bless you. And yes, architecture, that's where we finally get to the architecture part of this, of the presentation. So in this OpenStack environment that we've got set up, we have machines of two different architectures to start with. Most of it is x86, but we have at least a quarter of them are power machines, or running power architecture. They're running PPC 64LE, and but there are other architectures that are supported by both the GPFS and OpenStack. AIX being one of them, or IX being another OS that'll run on those power machines if you've paid IBM for the privilege. Z mainframes, it'll run both, and coming soon, I think OpenStack already works on ARM, I've read, but Spectrum Scale has not quite gotten that far along to have ARM provided. And so it turns out kind of like secret ingredient soup. There is no magic secret to running multiple architectures in OpenStack. They're as long as you've installed the correct packages on a power machine, it functions just like any other machine in an OpenStack cluster. You can create availability zones, and like I guess if sometimes you would split an availability zone off by geography, or you want machines that have a particular type of disk in them, you can just do the exact same thing with an architecture. And I shove all the power machines into their own availability zone, and they work great. It's yeah, it's great. Speaking of power, I had I'll spare you guys the history lesson on the power architecture, but it is open sourced, and Power 10 is out now. I should hope they have one of those in the environment coming up soon. AIX being the other operating system mentioned in terms of being able to run on power machines, also released by IBM. And then the talk promised also a kind of a bit of a breakdown of pluses and minuses, or gotchas that lessons learned from running this guy for a while. There's loads of positive results for running multiple architectures, because what's more fun than geeking out and having more than one architecture in your environment? Negatives for this would be, there's no support, so you're on a roll your own basis if you're going to do this. Being IBM, you might think we could just go grab RoHS P from Red Hat and have them support our endeavors, but they only support x86. And users tend to want to lean towards x86. That's what they'll grab because they are familiar with it. Even though they'll say that they can use power, they'll just kind of default to x86, which isn't necessarily a problem until you're trying to plan for capacity. Because once you've, if you go to the overview screen in your OpenStack environments, and your manager sees that there's 2 terabytes of RAM free, he says, hey, we've got plenty of room. And you say, no, all of those 2 terabytes are all in power machines, and everybody else is crammed into the x86 machines, and we're running out of space quickly. As for the cluster tool that I was describing, how we set users up and provide them a way to create GPFS clusters at any point in time, all day long, however they want to. This has had lots of positive feedback, lots of especially some of the performance or deployment-driven users deploy different clusters with different OSs multiple times, every day, every week, and appreciate not having any manual steps at all. Of course, going back to that network diagram that I showed you, another positive is that since users log into that Bastion node and all the VMs for any of these created clusters are all on private networks, corporate security scans never see any of them, and everybody's happy. Users don't have to register them. You don't have to take up any time or resources or cycles on those VMs trying to run antivirus software. Therefore, tests are a bit cleaner, and it just works out better. The network isolation provided by granting each user their own three networks works out well as well. It's plenty of overhead for Neutron, but just having three huge networks that you're trying to keep track of everybody's nodes on would lead to some network congestion, and everybody appreciates that not being the case, as is sometimes want in our bare metal environments there in the lab. A negative part of the way we've set this up is that some users you just can't reach. You give them this VM, it's small because we just intend them to log into it and run the commands to launch their clusters. We tell them, don't mess with it really, because I'm going to have to, run antivirus software on it to keep it up to date, to keep it compliant with corporates. I may need to update the OS. I may need to, Ansible may change and I may have to install that, or I may have to completely swap out the VMs. The VM itself, 85% of users will say, okay, I'll leave it alone and use it just like you told me. And then there's the others that will, they say, oh, I need to use this as a dev machine. Oh, I need a build machine over here. And, once you can't just go in and have your way with it, it causes not necessarily headaches, but it's just not as streamlined as it could be if the tool wasn't reliant on being on its own VM. What is next for OpenStack? So Poughkeepsie usually gets shortened to Poke, and you can wittily enough combine that with OpenStack and make OpenStack, not to be confused with DopenStack of ill-reported fame, or had its speedy demise. So anyway, the new environment Drake is already in flight as soon as I can get home and get back to work on it. Our old Frost environment is on hardware so old it still has IBM branding on it. So we have fresh hardware, a bunch of nice SR650s and 665s. We also ordered a new Flash System 5000, which means we will no longer be using that kind of old, outdated GPFS driver. It'll no longer be a dog food environment, but we'll be using the Storewise fiber channel driver, which I've already tested out, and grease lightning, man. We also bought some new 100 gig switches, which I'm looking forward to the improved network, and we plan an Ironic setup so that we can get, of course, bare metal installs of these clusters, but then we can stick in VME drives in some of these hardware and get users testing with those, because at the moment we don't have any in the environment. And as I mentioned, I got some P10s coming. That'll keep me busy for a while. Just real quick, I got to throw out some love to the guys I work with, because I certainly didn't implement this all by myself. If I'm lucky, I did a fraction of it, most especially Christoph Kyle, who wrote the original cluster tool, and PC, who did the original architecture of the Frost environment. And with that, I got nervous and talked way too fast, and I'm done early. Thanks, y'all.
thank you everyone for attending the chat with Olaf. We will be back at 1:30, and we have someone else presenting at 1:30. So please come back at 1:30. We'd love to have you. And if you have any questions for me, just let me know. All right, have a great lunch. Bye.
Okay, now testing. One, two. Hakeem, testing. 1, 2. Is that better? And if you need audio, do you need audio?
With the slides?
No.
From the laptop? No.
Over again, Hakeem? Yes. That's what we're working on.
He's turning it down a little bit. Try it on. Yeah, you can try it on.
Hello. Hi. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3, 4, 5, 6. Infinity.
I think it sounds good now.
Good? Excellent.
Okay, hang on, I'm going to test in just a moment again.
Are you excited about your talk?
Monitoring station, we need to
Are you
test
excited about your talk?
the Horseman in 107, over.
Excited and looking forward to being done at the same time.
Okay, after this talk, you're not speaking again.
I will be speaking on Saturday.
Okay.
Yeah, so I have one more to deliver this weekend. Busy weekend.
Well, that's cool though.
Oh, okay, I think
So
this is working.
Hi.
So I will let you
It
all
sounds
figure
good.
out the
Yeah?
audio.
Okay. I'm going to turn this off.
Sure.
Okay, no problem. See you soon. See you in a bit.
And that way you're not tethered to it or whatnot. And the volume was down on this on that.
On the microphone too?
Going out. It was in the room, but it wasn't showing out. But there, everybody's having a fit up there because it's been so low all morning. So it's saying, don't do this. Okay.
Talk to us live. But now we know.
Why did it say low? Oh, probably sensitivity. Testing. All right. Isn't that too loud?
It feels, I would say,
Fe-
strong.
Feels echoey, yeah.
It gives you a demanding and commanding presence. It's almost ethereal.
I better don't sneeze because the room the doors are gonna blow out. Yeah.
I think the conference is supposed to provide a timekeeper, but if not, I'll do it for you.
It's all right. I've got a clock here. Yeah. Got half an hour.
Yeah. Where everyone come from? I'm coming from India. From India, so perfect, no problem.
No problem. Yeah, sure.
No, actually, I came via Singapore.
Okay.
It is pretty loud.
Oh, is this better for you? Yeah. This is what we use most of the time.
Maybe I can just get this away from my mouth. How about that? Oh, well, look at that. Look at that.
Yes.
Solutioning.
Okay.
So how many of you familiar with RDO? OKD? Ah, that's it. We got a few.
I think Red Hat OpenStack 18 more or less sounds the same topic.
It's this, but that's the community version of it. That's the upstream of Red Hat OpenStack services on OpenShift. Very long name. ROSO was the acronym that people like to choose. But that's exactly what it is. And shameless plug at the end, you'll hear about ROSO, because I do work at Red Hat.
Just curious to understand, how does this compare with KubeVirt or Red Hat OpenShift virtualization? That's one area.
Sure.
And the second area is Red Hat as a company. My company builds solutions surrounding the Red Hat platform.
Yeah.
So Red Hat as a company, is it going more towards OpenShift virtualization?
Yes.
Or is it going more towards this kind of architecture?
More towards KubeVirt. Like KubeVirt is my OpenShift virtualization. That's actually my primary product. That's what I specialize in at Red Hat. This, bit of a side gig. Because I did spend previous 10 years or so doing OpenStack. But to answer your question, I think there's much more emphasis put on OpenShift virtualization. But OpenStack's still there, not getting sidelined yet.
Because we build a cloud management platform surrounding OpenShift
Mhm.
plus OpenStack, Red Hat OpenStack.
Mhm.
So now, if we have to achieve a VMware's site recovery manager kind of feature,
Yeah, it's tough.
yeah,
OADP is the answer, somewhat.
yeah.
But we can talk about that later if you want.
So before we investing developers and building that feature, I just want to know where to focus on.
Absolutely. OpenShift is a container management platform, yes. OpenStack can manage both containers, VMs, bare metal. OpenShift centralizes on containers, but it can also manage VMs.
How different is OpenShift compared to Docker?
That's a very long topic. Docker is just an engine for running containers. OpenShift is a platform with a lot more than just running containers. Short answer, but.
But you don't use Docker inside.
We use something called CRIO, C-R-I-O. Yeah. Container runtime something. I wish I remembered. C-R-I-O. It's a very, very simplified way of launching containers. But I think we're just about on the dot here with time.
Yes, we are. Hi, everyone. Good afternoon. Today we have Mr. Lecky, and he's going to do.
You almost did it. You almost did it.
He's going to have his talk on RDO, OpenStack, OKD, Kubernetes, the perfect combination for modern enterprise data center. I'll let you take it away, Mr. Lecky.
Thank you very much. And you almost did it. Very close. So we're going to be talking about a couple of technologies today. There's only 30 minutes, so we're going to be glancing a lot of these topics on a high level because there is way more to be said here. what's the agenda for today? We're going to talk about OpenStack. People here attending the OpenInfra days probably sorry, familiar with it to some degree already. RDO, I'm going to throw some acronyms on you and I'm going to talk about them in detail. RDO, OKD, SCOS, FCOS, OpenStack Kubernetes operators, and then RDO on OKD. Seemingly long agenda with a lot of acronyms. Should be enough time here to unpack each in more detail. OpenStack. How many of you attended the OpenInfra keynote today, this morning? A good bunch. So I won't be going into too much detail, but it is a infrastructure as a service platform. It aims to provide infrastructure services for networking, compute, and storage. Those are the core three areas. It allows you to manage pools of servers running VMs, containers, or maybe bare metals resources on a large scale. It's been out for 15 years. Today, we will be celebrating its 15th year birthday. This has been a while. I've been dealing with OpenStack for about 10 years. Or something like that. I think it was Havana or Grizzly. So that will be maybe even more than 10 in that case. 2012, and we're 2025, so see? What's that?
2014.
Okay, so we're right there. it's been, yeah. So it's been a while. There's been so many installers, so many iterations of how you install it and deploy. And this presentation is going to be about yet another new way to deploy OpenStack. What else can we say about OpenStack? That's probably enough. It's probably enough if you've attended the keynote. RDO, first acronym to unpack. RDO stands for RPM distribution of OpenStack. RPMs are just binary packages that you can install software with on Red Hat Enterprise Linux or any derivative of such. Why does RDO exist? It's an open source community project designed to build packages from OpenStack releases. So OpenStack follows a 6-month release cycle. Every 6 months you'll see, maybe with a couple weeks delay, a new RDO release of RPMs pushed out to the CentOS mirrors for that OpenStack release. It just packages Nova, Neutron, Keystone, all those components of OpenStack in nice RPMs, and you can install those on a CentOS system. If you want it, you can install it on Alpine. You can install it on anything where RPM will run. Why does RDO exist? RDO is designed for you as a community member to be able to take that code that the developers, and I'm sure there's a few here maybe contributing to OpenStack, that they work heavy on and release it to the current release. And you can pick that up in the form of an RPM and install it and give it a shot, right? So its main purpose is testing and allowing people to see what's in the new release. And I already mentioned, we follow the 6 months release cycle, and that's adopted from the OpenStack release cycle. The RDO packages are being published to the CentOS mirrors, so you can find them on the CentOS mirrors. You can. The primary target is CentOS 9 Stream, so the latest version. Yeah, community of people who build OpenStack packages for any consumption. OKD. Yes, please. Yeah, absolutely. CentOS Stream. CentOS 9 Stream is the release on which we're going to be talking a lot about here. There's been some changes in CentOS induced by Red Hat in the past few years. I don't like talking about those because I don't like those changes. But nevertheless, CentOS still exists. Yes. The next acronym to unpack, OKD, OpenShift Kubernetes Engine. Something very similar to OCP, OpenShift Container Platform. In fact, OKD is the upstream version. That's where the development happens on OpenShift. If you read the docs, OKD docs or OpenShift docs, and you find the word origin in it, OKD is commonly referred to as the origin to OCP. Basically the upstream distribution of OpenShift. So why does OKD exist, right? It gives you a free and open source way to run Kubernetes in a prescribed OpenShift way, right? OpenShift is an opinionated deployment of Kubernetes. There's a lot that comes with it, right? So out of the box, when you install Kubernetes, you don't get things like a web console, right? You have to install something extra. You don't get operators. You don't get stuff to expand some other functionality, like an image registry, right? Like everyone needs an image registry when running OpenShift. All of those things, OpenShift bundles, and OKD follows the same ethos. Out of the box, it gives you a lot of that tooling that'll help you to run Kubernetes. It also comes with a nice framework for doing upgrades. Also comes with methods for configuring networking on the nodes. There's operators that are dedicated to that. It also supplies a bare metal load balancer, right? A lot of these things don't exist with Kubernetes. So it's a nice way to augment Kubernetes with some tooling that'll make it more enterprise ready. And OKD is just the upstream distribution of OCP. FCOS and SCOS. First, let's talk about what an operating system is that runs on OKD, that runs beneath OKD. Like, on what operating systems are you going to run your workers and master nodes, your control plane and data plane? So in OpenShift, we talk about having an immutable OS. A truly immutable OS is one where the file system is read-only. You can't make any changes to it by definition. Here we introduced a concept of controlled immutability. So FCOS stands for Fedora Core OS, and SCOS stands for Stream Core OS, stream as in CentOS stream. So Core OS can be built on many platforms. Red Hat, when Red Hat ships OpenShift, it builds Core OS on RHEL. But RHEL is available with a subscription. So when the OKD community needed to pick an immutable operating system to run OKD, they were faced with a dilemma. So they went with Fedora Core OS. And that worked for, I think, a few years, all the way until, I think, 2013, when the build process for that Fedora Core OS ended up bleeding some bits from RHEL into it. And Red Hat didn't like that, because they wanted to monetize on that. But the solution to that was to stop building. And that was unfortunate, because in between 2013 and 14, there were just no builds of OKD, because there wasn't a suitable immutable OS to run it on. In that time, the community was working hard on building a version of Core OS based off of the CentOS Stream 9 sources. At the end of 2024, in December, so not too long ago, 2-3 months ago, a first release of OKD based on CentOS Stream came out. That was 4.17.0. So we're finally over this hump, and it's much easier to install OKD because there is an immutable OS that's supported with it. During that transition period, it took almost a whole year, I think. You could have done things like install 4.15, which was the latest release, and then just kind of stick using to that. And then someone said, okay, well, we can mutate the OS from Fedora CoreOS to SCOS, to CentOS-based CoreOS. Version 4.16 is made just for that. So if you have an OKD cluster running 4.15 and you cannot reinstall that cluster, you have some workloads which are you running on it. The only way to upgrade that is to do a hoop through two versions. You do an upgrade to 4.16. 4.16 is not suitable for even lab work. It's suitable for one thing and one thing only: mutating that Fedora CoreOS into SCOS, into CentOS. And then you do another upgrade to 4.17.0, already running on SCOS. So FCOS, built from sources of Fedora Linux, supported until 4.15. SCOS, Stream CoreOS, based on CentOS Stream 9, supported from version 4.17. And that is the current version right now that OKD releases. OpenShift, the Red Hat downstream version, OpenShift Container Platform is at 4.18 right now, so it is a version ahead. All new builds of OKD are going to be using CentOS Stream, aka Stream CoreOS, as its operating system. We're done with Fedora for now, although I think there might have been some initiatives there to clean up the Fedora sources, but that might have been too complicated. So we unpacked the next acronym. This one is not an acronym. I haven't seen an acronym for that one. So now we've got OKD, which is our container platform, running on CentOS Stream 9 CoreOS. How do we bring OpenStack on top of that? I think it was 2 years ago when this new way of installing OpenStack was proposed. How does it work? So until now, if you've been using OpenStack, especially the Red Hat flavor of it, how many of you are familiar with OOO? Oh, no. Yes, I have been using OOO for many years myself. I always thought that I was the one that had the most patience, and that's why I was so good at it. But here we are, and OOO is no more. OOO was deprecated, and this was a Red Hat decision, and its replacement was this, OpenStack Kubernetes operators. It's a new way of deploying OpenStack, especially the control plane. We're talking about where your APIs listen, your Nova API, your Keystone API, your Cinder API. I'm probably forgetting a few. Neutron, important to have networking. If you remember on OOO, you would log into a controller, you would see all these APIs listening in pods. You do podman ls, and they're all listening in pods. So they were already podified. So they took those and implemented those using operators. Seemingly same container images, but their life cycle is now controlled by operators, Kubernetes operators. So the Kubernetes operator standards, more or less on a high level, there's a controller, that controller comes in, and that controller is the one that starts the deployment of Nova API. It controls how many replicas Nova API will have, and it will do the same thing for Keystone API, Cinder API, all the services that you decide to run inside the OpenStack environment. And it, of course, runs it on Kubernetes. In our case, I'm going to be talking on how to run this on OKD, which is the community distribution of OpenShift. So along with that comes a set of CRDs, custom resource definitions of how these controllers interact with running the OpenStack services. And of course, that's a new method that completely brings the end to OOO. So no more OOO, and we're going with native Kubernetes. But that's not the end of running OpenStack compute nodes on RHEL. We can still run those on RHEL, and I'm going to talk about that in the next slide. RDO on OKD. So what if we want to put this all together? We have a container platform, we have a native Kubernetes way to run OpenStack services supplied by the OpenStack Kubernetes operators. And then we've got RDO, right? RDO is the binary packages. They still get released every 6 months. So on a high level, the operator images are built using they're built using Kubernetes operators. There's actually a custom build process there supported that you can pick any release you want that's been released. There is Antelope. That's the release from 2 years ago. Yeah, we're on E. Yeah, so 2 years ago. So for Antelope, you can download these straight off of Quay, so you don't have to build those. You can push those and run those. There's a framework for building your own images called TCIB, the Container Image Builder. Pretty self-explanatory name. I think it's a Python project as far as I remember. And it's designed to do one thing and one thing only: building packages, building container images to run OpenStack services using the RDO packages. And then we've got the OpenStack Kubernetes operators. The main operator is called there's a meta operator called OpenStack. That triggers all the other operators, that sets up the control plane. Then there is an operator called data plane. That sets up your compute nodes. Now, all that talk that we did about immutable OSs, that's only Kubernetes. The compute nodes still run on RHEL. So here's where a lot of similarities you'll find with the old style of running OpenStack directly on RHEL or any other OS. The compute nodes will still run on RHEL. And then, of course, important point to make, because we're running on OKD, we can only use CentOS core stream. No more Fedora, right? Without OKD, we have no RDO running on it. So in order to have a working platform, we need to use that supported operating system. Now, if you want to try this yourself, the installation of OKD can be pretty convoluted, but doable. Could probably do a dedicated presentation for that. But if you want to do this yourself, don't do this in prod, little development sandbox, get a VM that is capable of running nested virt, or perhaps a bare metal host that is capable of running VMs. It's going to run only one VM, so it doesn't have to have too much CPU, and I forgot what the exact specs were. It's like 100 gig disk, maybe 32 gigs of RAM, 16 CPUs, nothing crazy. You can run all of that on just one host. And the way this is laid out is we're going to use something called CRC, Code Ready Containers, and that is used to deploy OKD. So it kind of skips the complexity of deploying OKD. It just pulls in a minimal sandboxed one host version of OpenShift, actually OKD in this case, and runs it on your laptop or VM, whatever that is. I run it on my laptop, it works perfect. Install YAMLs, it's a bunch of YAML definitions that use the OpenStack Kubernetes operators to stand up the whole environment. So you clone that from a Git repo, and then you do OC apply or kubectl apply, and it creates all the OpenStack services. And now you have the OpenStack control plane up running on Kubernetes. It's really that simple. It is amazing how someone put a lot of work into it, and I forgot who that was, but I want to give credit where credit is due. So you do that, and the next thing is, well, in order to test a full OpenStack cloud, we need a compute node. And that's why the node where we run this little mini POC dev environment should be capable of running virtual machines. Because that virtual machine will be created using CentOS 9 as its base image. And the OpenStack data plane operator will invoke Ansible. Ansible will log into that host and will install all the required packages in order for that machine to become an effective compute node. Connected to the data plane, running in podified deployments on OKD. There's two networks. I don't know if you can see that in this deployment, in this picture here. The top bubble that connects those two is called the default network. This is where all the OpenStack internal networking happens, like the public API, like storage management, internal API. And this just exists between the OpenStack control plane and the VM. And there's another network called the CRC network. That network is where OKD will expose public routes hosting the interfaces of OpenStack, like the OpenStack Keystone Public API endpoint, public API endpoint for Neutron, and all the services that we talked about. By default, there is no access to this from outside this host. But if we have a network like that, it's just a bridge on your host. It should be pretty easy to expose that to the outside. Let's just install HA proxy on the same host. And by putting that HA proxy in there, you expose all these routes from OpenShift, and now you can access all those public API endpoints from outside the host. Again, I wouldn't do that in prod. What I'm showing you to do here is experiment with it, right? When you do a deployment like that, yeah, it runs on one host, right? When Red Hat runs their stuff, it's going to be on more than one host. So it's not a supported production deployment, but it will behave very, very similar to what you'll see from Red Hat. Yes, please.
So when you deploy on one host, are you still using the Neutron software?
Yeah, absolutely. Neutron is one of the projects that will be built for you and deployed by the OpenStack Kubernetes operators. So we're not getting away from Neutron. So where does that bring us? You've experimented with it, you run your little developer sandbox, and we talked about Red Hat services on OpenShift. Red Hat services on OpenShift is doing this, but in a production-supported way. So the deployment methodology will be very similar, right? We need a container platform. That happens to be OpenShift container platform. We need immutable OS. In this case, that will be a Red Hat Enterprise Linux CoreOS. So CoreOS built from RHEL sources. Once you deploy all of that, you've got your VMs running. You can call Red Hat and something doesn't work. And that's really the whole benefit of a Red Hat subscription by running that. RDO on OKD, great way to get yourself familiar with how Red Hat OpenStack services on OpenShift works. I've got a bunch of references here. Of course, the openstack.org website. RDO project, that's where you can find information of how the RDO RPMs are being built and where those are hosted. OKDIO, instructions how to set up OKD, and in general, how OKD works. OpenStack Kate operators, posted in the GitHub repo. SIGs, CentOS.org cloud, that's the cloud interest group, special interest group. This is where you can find information on how to put together that little POC environment with running on a VM or a single host that creates OKD using CRC. There's a full guide on it. I probably copycatted most of it for this presentation. Very useful resource. And then the last link is if you're interested in Red Hat OpenShift services, Red Hat OpenShift services, Red Hat OpenStack services, and OpenShift. Go to the last link. Happy to share those slides. We probably have 4 more minutes for questions.
Now, when it comes to a, let's say a kind of a production environment,
Mm-hmm.
for a hyper-converged infrastructure, especially with OKD, are we going to use a chip for the distributed storage, or is there some other package?
Ceph. Yeah, so when you install the control plane of Rosso, and we're talking here about Rosso. Oh, by the way, you can optionally install Ceph on that one host as well. But now, switching gears to this, right? You can install the control plane on a 3-node, that's called a compact cluster. Compact cluster, so those are 3 nodes. They're acting both as masters and workers, so they run both data plane and control plane services on them. And in addition to that, you can use ODF to deploy the local storage for that cluster. So that ODS is based on Ceph. Yeah.
So does Red Hat recommend a converged architecture for prod or hyper-converged architecture?
It really depends on how busy that environment will be. You know, I won't be able to make a recommendation without you telling me how many VMs a day you're going to be creating. Is it 2 a day? Oh, well, go with hyperconverged, save on some servers, right? But if we're dealing with a very busy environment where the APIs are getting constantly hit, like internal cloud used for testing servers, which are getting hundreds of servers deleted and created at a time, yeah, I would probably put that on some external storage just to take that storage load away from the hosts running the control plane, so your APIs stay nice and responsive. So there is no single recommendation, right? It really depends on the workload.
And my last question is, the immutable operating system is for security reasons or performance reasons?
It's mostly for security reasons, right? I mean, you imagine it's a controlled environment where changes are only allowed to be done in a very specific and audited way. So a true immutable system would be entirely read-only. That's not entirely the case. Right. So you can make changes, but in very, very few areas, very specific areas, and those changes are introduced using something called machine configs. So there isn't that easy to just go in and configure whatever you want. It's a very special kind of Linux.
How are you enforcing that immutability?
Well, I mean, it's mostly permissions, right? You won't be able to access things. Some of the areas of the file system are not writable. And they only allow changes to be done through machine config. Machine config is a custom resource definition originating from Kubernetes.
What if you have a security vulnerability and you have to update what happens?
Well, kernel updates, just like in any other Linux system. No, actually, we can do kernel updates now without rebooting the host. But most likely that will involve rebooting the host. So when you upgrade the OpenShift environment, typically you can stagger it, right? You have multiple hosts. You don't have just one host like in our POC environment. So you can upgrade one by one, and you can drain the node from all the workloads that run on it. The workloads are containers. They get migrated to another host. The machine gets updated, reboots, comes back online with a new version of maybe the kernel, maybe some more, maybe some operators that get upgraded usually with it, and then rejoin the cluster.
Thank you so much.
Thank you.
Please give a round of applause. All right, please give us a few minutes while our next speaker gets set up. Thank you.
Okay, hello everyone. Can you hear me okay? Nice, all right. I have glasses and all kinds of things, so if this gets annoying, we will switch over to some other microphone that will also hopefully work. Just shout out in any time. I mean, if you want to, you can roll the introduction and we can go.
Hi, everyone. Good afternoon again. We have Ms. Ildiko Vansha, and she will be talking about Kata containers, security, and containers without compromise. So this is going to be an exciting talk. I hope you all stay tuned. Take it away.
Thank you. And well, round of applause to you as well. I know that we are getting towards the middle of the afternoon. It's after lunch and all those kind of things. I'm grateful for the rain outside, so we have all of you in the room now. And today I will talk about Kata containers. Before I do that, let me say just a very few words about myself. So I'm Ildiko Vansha. I am Director of Community at the Open Infrastructure Foundation. Before coming to the foundation, I used to work for Ericsson, so I have a little bit of a telecom background, but I was working more on the cloud execution environment side of things, even within Ericsson, so I have a bit of OpenStack background and those kind of things. These days, I focus more on community management, so I am a community manager for, well, drum roll, Kata containers, as well as the Starting X project. I will be talking about that other one on Saturday, in case you're interested in a distributed cloud platform. But today I will focus on Kata, and for full transparency, I am a community manager, which means that I am not an active developer or user of either of these projects, but I can find you the people who are. So if you have very deep dive development type of questions, I will find you the person who can give you the most detailed answer. So please take me up on that. And also during the talk, after the talk, feel free to come chat about Kata containers, ask questions. I would love to connect with all of you who are already users, contributors, or interested in becoming one or both of those. So without further ado, Kata containers. Kata containers is an OCI-compatible container runtime, fully open source, and OCI-compatible will become important later. You will see this is, I think, as close as you can get to standardization in the cloud-native container space. So Kata containers, I think, is a pretty cool project because it kind of creates a fusion between containerization and virtualization technology. And I like to look at it as an evolution path for both. I mean, depend on who you talk to. Sometimes people talk about containers like they are the next evolution step and they are the ones that are, putting VMs out of commission, even though I think containers have been in existence overall just as long as virtual machines have been. So Kata containers is a great example how you can get the best out of both of these in one simple package, which is a container runtime. Now, why would you even do this? You might ask. So when Kubernetes and containers just kind of burst into the market, everyone got really excited, and you might think that all of a sudden everyone just runs containers everywhere. Now, that is not exactly the case. Like, I remember talking to telecom operators, and it turns out that, yes, they are running containers, but guess what? They are running them in virtual machines. And then you look at public clouds, and yes, they are running containers, but guess what? They are also running them in virtual machines. And then you remember how everyone has been complaining that virtual machines are big, they are heavy, they are slow, a lot of overhead, why do we want them anymore? But it turns out that they are still very useful. So what Kata containers does is it utilizes the hardware virtualization, but strips down the virtual machine and virtualization layer as much as possible. Like, who needs a floppy disk in the virtual machine anymore? I mean, do you all even know what that is? I remember still, installing Microsoft Windows from 8 floppy disks when I was a kid. It was an interesting experience, but they are just not in use anymore. So you don't need that in a virtual machine either, and along with a lot of things, you just don't need that anymore. But when it comes to that functionality of isolation now, that is something that you need even more than in the past if you think about, cybersecurity and how we are living very digital lives, and, you have to keep your application, your data, and all your things safe and, well, away from others. So that's what you can do with Kata containers. And I mentioned already that it is one tiny package, a very compact package. So what Kata containers is trying to do is really seamlessly integrate into the infrastructure that you are already using. So, kind of not even see that it is there, but it is still making a huge impact. So what it means that, I mentioned it's open source, so it's fully available anytime. If you want to grab it, you can look into the source code. If that is something that you are interested in, hopefully you are, you should be able to do so. You can use it with Kubernetes, you can use it with Docker, just like any other container runtime, because even though the container is running in a virtual machine, it actually looks and acts like any other container. And on the virtualization side, you can run it with different hypervisors, so you don't have to be stuck with just one. You have options to choose from, and the same goes for hardware architecture as well. So I mentioned this is pretty cool, but it's actually not that new. The whole idea started when Intel launched the Clear Containers project in 2015. So that was, 10 years now? Crazy. And then Kata Containers, the open source project and community, was launched in 2017 from actually 2 code bases, hyper.sh is runv, and Intel's Clear Containers. And you can see from this little history evolution slide that in just under 1 year, the 2 communities as well as the 2 code bases merged. So Kata Containers 1.0 was released and available, already OCI compliant, compatible runtime, and providing you the baseline of this technology solution. And by 2019, companies like Alibaba, Baidu, Huawei, others were running it in production. And what's interesting about some of those company names, like they are in China, which means that if you're having a solution there and deploying it, that infrastructure has to scale to an enormous size, just because, 1.5 billion people, that's a big number. So those companies really made sure that Kata is tested under load on a high scale in production. And that was, again, 6 years ago. So if you have any doubts whether or not it's ready for prime time, you can be sure it is. It's well tested. And since then, Kata 2.0 started to experiment with Rust, because originally the Kata runtime was implemented in Go, but technology evolves, programming languages evolve. So the community is trying to make sure that the runtime also evolves with the technology and they don't get stuck with one decision just because they made it in the past. So they are slowly but steadily are working on not just having a Rust agent that they had in the 2.0 version, but actually having a full-blown, full-feature parity Rust runtime, which the experimental version is already available in the 3.x release, because the latest release of Kata is 3.14 as of today. So you can already install the experimental Rust runtime and play around with it. It might not have the entire full functionality as the Go runtime does, but it does work. And it is promising even better performance than what the original runtime has been having. And there is a sibling project to Kata Containers, which is called Confidential Containers. I will talk about it just a little bit later, because that kind of gives an additional layer of that security and isolation than what Kata already has through hardware virtualization. And ever since, both the contributor base of the community is growing as well as the user base of the community is growing. So I just threw out a few logos of companies who are using as well as maintaining Kata containers together. There are even more, so it is just a highlight of the most active contributing organizations. I like to have this slide and these kind of slides because you can see the organizational diversity. So that really shows the trust that companies have in the project who are, again, using this in production and integrating the project into their solutions and products. And what it also tells you, it is a great example of a collaborative effort and how these companies are investing in the project. And I would like you to remember the word invest, because open source is great. It's freely available. You download it, you use it, great. Someone else will maintain, not my problem. However, it is kind of your problem if you are using an open source project, deploying it for personal use, production use, part of your products, and especially with new legislations and regulations around the globe, companies are getting held liable for any issues in their solutions and products that they're selling, including software bits and pieces, including the open source bits and pieces in those solutions. So when it comes to investment, that word will really gain new meanings and is gaining new meanings. And when you invest in an open source project upstream, that means that your maintenance cost is actually going down. And this is what all these companies and others as well in the community recognized. So they are already showing a great example, and I'm hoping that I will see all of you in the community very, very soon. So, little technology overview. Scratching the surface most probably, but it is also only a half-an-hour session, so there is no way of going too deep in this amount of time. So as far as the concept is going, it's probably pretty straightforward at this point, and this slide is just explaining to you that containers are great, but when it comes to traditional containers, they're actually not that good at containing. And I stole this line from our general manager, Thierry Perez. So shout out to him for teaching me this good one. So you can see how through the shared hardware resources and the shared Linux kernel, if you have a little worm in one of the containers, it is really super easy to get into the rest of the containers in that system. Now, it is really annoying to start with, but then it also shows you really well that if that server, that host, was shared between multiple people, this could be in a cloud environment, for example. Like, you have someone else, you don't know them, you don't know if they have bad intentions or not. So if it's that easy to get over to the other container, then would you really want your container to run next to somebody else's that you don't know? Probably not. So this is what Kata Containers helps you with, because again, whatever there's an intent within that virtual machine, they still have a lot of effort to chew through all those layers to get over to the other one. And I did not draw this diagram, so before I move forward, let's see how well you're paying attention. There's a little weirdness on the diagram. Anyone spots it? Yep. It's actually mirrored, so hardware virtualization is written correctly, but I think the letters are just flipped over. I have no idea why. I truly don't know. I will need to figure out who created this diagram, but it just cracked me up when I realized that there's that little mix-up on it. So thank you for paying attention. All right, so, yes?
What does hardware virtualization mean? You virtualize in the virtual machine, the software.
I mean, you have the hypervisor and the virtualization layer on top of the physical hardware. So it gives you virtual hardware resources like a vCPU. Does that?
Yeah. I mean, since
Yeah.
you have another virtual machine on top of it.
I think it's just the way to kind of visualize the hypervisor and that virtualization layer to kind of give an idea that on the left side, I don't know if you see the little hand. So you have the shared hardware resources, and here these are kind of moving over to this hardware virtualization layer, which is written very weirdly. And the virtual machine has its own resources. I mean, it thinks it does. So that's all that it really means. It's just a high-level overview of how virtualization works if you would need to explain it to, I don't know, a 10-year-old, probably.
The container virtual machine is doing that hardware virtualization, each of them.
The virtual machine does. The containers have nothing to do with it. So inside the virtual machine, you have your container, like the namespace and the process. It is the actual container part. And technically, it doesn't really have an idea that it's in a virtual machine. And it shouldn't, really. So the point of it really is that inside the virtual machine, you have the container that acts as a regular container, just like if it was running on the host, on a bare metal server. But you do have, in fact, the light, thin virtualization virtual machine around it. So it is protected through that. And it uses the resources just like in the bare metal case, because it has no idea that these are not the direct hardware access at that point. So on the seamless integration part, I will not spend a lot of time on the slide, but what you can see is, and this is where the OCI compatible runtime part comes into play. Like you can see on the top part of the diagram that you can use Kata containers with both OpenStack as well as Kubernetes. With OpenStack, like you can run it through Docker, and like you run a container with runc as a container runtime. And if you look at the bottom part of the diagram, you can see that the left side of both of these diagrams are technically the same. So the first place where you see a difference is that the runtime is not runc, it is Kata containers, it's the Kata runtime. But because it is OCI compliant, so the interfaces are implemented accordingly, it just fits into the system just like the other runtime does. And there is the other difference between the two parts of the diagram is, again, that virtual machine. But inside that virtual machine, the container looks and acts just the same. And in Kubernetes world, this all goes through kubelet and through CRI-O or containerd. You could invoke runc, or you could invoke the Kata runtime. Now, here's the trick. In Kubernetes land and terminology, what you have inside the virtual machine is actually a pod. So I think it's pretty cool. So what it means, hopefully that's the next slide. Yes, multi-tenancy. So Kubernetes is a container orchestration system, open source, and it was designed with the goal and intention that you should be able to manage and orchestrate containerized workloads flexibly, easily, all the things. And it does that really well. However, what that also means is Kubernetes was designed with the idea that someone else takes care of the infrastructure for it. So it runs in a cloud platform, again, somebody else takes care of it. So when it comes to things like multi-tenancy, what you need to do with Kubernetes without Kata containers is, you can see on the, I think it's your left side too, on the left side of the diagram, is that if you have an environment that is shared by multiple tenants, like multiple users, customers, then the way to isolate their workloads works by actually running those workloads and those pods on separate nodes. I mean, bulletproof, I will not argue with that. You can still get to those servers through the network if you can manage to do that. But again, other than that, that's the most bulletproof way to implement multi-tenancy with Kubernetes. However, if you think about it, depending on what those workloads are, this can be pretty wasteful from resource usage perspective. Like if those workloads are not really utilizing the entire servers, then why do you really want to run them on 3 different ones? So with Kata containers, because of that additional virtualization layer, you can run all those workloads on the same node. And it creates you the opportunity to have multi-tenancy within Kubernetes, just like if it was designed like that by day one. And I'm not kidding with you. It is documented in the Kubernetes documentation, so you can look it up how to actually make it work in your deployment if you have a deployment already. Another newer concept in Kata containers is an interface that is available in Kata that is called remote hypervisor, or you can also refer to it in Kubernetes land as peer pods, which makes it possible, for example, if you have a cloud and you want to burst it out into, holy moly, I'm running out of time really awfully fast. So you can actually extend your workload out into the public cloud through the remote hypervisor interface. And this is pretty cool. You can see it on the slide that there is a different runtime class. And like you can imagine that the public cloud is maybe AWS, so you can create an EC2 instance. And then when it comes to networking, that goes through a network tunnel to get your Kata pods in the VMs connected to the Kata deployment and the runtime in your current cloud or environment. So it is a pretty cool concept. One thing to note though is this is something that you need to implement on the user side. So if you're looking for an implementation of it, the Confidential Containers project does provide one for you. Features. Check out the latest version of the documentation. The point of this slide really is that it gives you networking, storage, and all the things that you would expect from a container to be able to give to you. And the community is also working on, adding more hardware support. So GPUs and things are also supported in Kata containers. Just think back the slide with the logos and NVIDIA for a good example of all that. And I think I have roughly 3-ish minutes left. So one thing I would like to mention about releases, without going into details of what's inside Kata 3.x these days, is that Kata has the community came up with a simplified release process, which means that they are putting out a minor release every single month. They don't have a stable branch for those minor releases anymore. So if you want bug fixes, if you want any enhancement on any feature, then you have to use, download, deploy the latest and greatest. So please make sure that you are running that, because there is no stable branch that gets, bug fixes backported. So that concept really goes more for the major releases, which is planned, 4.0 is planned for 2025, and the really big item should be and will be the Rust runtime available with full functionality, same as the Go runtime. And in 4.0, the Rust runtime will be the default one, and the Go runtime will be deprecated. So that will be the biggest change once 4.0 kicks in. You can run Kata on bare metal, you can run Kata in the cloud, and as you can see, the hardware diversity is also there, Intel, AMD, ARM. Whichever you favor, you should be able to run Kata containers on top of it. And I will give you a little glance into confidential containers, and then I will probably end there, and then I will be only like 30 seconds to a minute over. So confidential containers is a sibling project to Kata. The two projects share a good chunk of the contributors. Many people are involved in both. Confidential containers has the mission to bring confidential computing methods and techniques into the cloud-native space. So think about things like trusted execution environment. So when it comes to isolation, it is actually in the hardware. So think about the main CPU unit, which protects data as well as your application code that it is executing at any given time. This does require hardware support, so you need hardware that implements confidential computing techniques and provides the trusted execution environment support. And you also need software for that. And if you remember those two diagrams with like how to integrate and enable startup Kata in like OpenStack and Kubernetes environments, you can see on the left side here again, kubelet, containerd, Kata runtime. This is how it all starts. And you can see how confidential containers does have the implementation of peer pods. So what it means that Kata containers is the vessel to be able to use confidential containers. So if you are interested in this technology, then you will need to use the two projects together. They are closely integrated. And based on my interaction with users, you really can't find this technology and this combination anywhere else in the market. And this is all open source, both Kata and confidential containers, Apache 2 license. So you have access to the code, but even more importantly, you have access to the communities. So I would encourage you to reach out to me if you need guidance on how to reach out to the two communities, or look them up online, join the team meetings. Both communities are on Slack. Kata has their own workspace, Slack workspace. Confidential containers are in the CNCF Slack workspace. So reach out to the communities, work with them, fill out the user survey if you're already using the project, and make sure to give feedback, report a bug if you find it. If you fix it, it's even better. So make sure that if you become a user, you also invest in maintaining the project upstream, because that's what will guarantee your success, the project's success, and its sustainability. And with that, I will stop here.
Great. Hi, everyone. Good afternoon. Just give us a few minutes. Our next speaker is Patrick. So give us a few minutes. Thank you. Hi, everyone. Just give us a few more minutes, having some technical difficulties. Thank you. Hi, everyone. Good afternoon. Today we have Mr. Patrick, and so he's going to be talking about running AI LLM applications on Kata containers. Um, so take it away. Okay, it's on the top, very top.
Thank you. Thank you very much. Good afternoon. I'm lucky, maybe it's raining, so there's a lot of people to visit me. Thank you very much. And maybe some of you would like my French accent. Some will not and will leave. Sorry about this. I'll do my best. My name is Patrick, arrived yesterday from France, and I'm going to take the continuation of the previous presentation on Kata Container. So I had to review something just to escape some duplicate hallucination, okay? So I've got a couple of slides, and I'm not lucky because maybe some of you have noticed that internet here is very, very bad. So I cannot demo online, I'm sorry. But you're lucky because I did some movie yesterday, so we'll watch some movie. That's it. Okay. So my presentation agenda, there is three things. I don't want to have this presentation technical because it will not last 5 minutes because I'm not a technical guy. Okay. So I want to speak about something else, like legal context in Europe. Why we move to Kata Container, it's important, okay? Second things, I will just review, just to show you how it's easy to migrate to a Kata container runtime. It was said just before, okay, during the previous presentation, the difference between a standard container and a Kata container. I will show you how to move from one to the other one. And third things, just to demo an application, which is an open data application called Data for Citizen, which is powered by OpenAI application. So you will see how we use OpenAI plus scikit-learn. I don't know if some of you know scikit-learn. Raise your hand. Okay, thank you. So we bundle scikit-learn with OpenAI, and we use LLM generation to build, for example, dashboards. So you will see it's really impressive, plus some other things. So first part, I will go very fast on this because it's not really interesting. We've got many and many rules in Europe, same in US. And we've got two rules. First one is GDRP, and second one is now NIS2. Those two rules are really changing the way for SaaS application, because you really need to follow many and many rules. For example, for NIS2, maybe you can read better than I can speak in English. It's like a directive, so it's like a bill in US, just to ask to hosting company to follow lots of rules about security. Okay, so for this, we need to change many things in our application. We need to update the component. We need to turn from simple application to container application. We need to have lots of security things with our hosting company. It's become really, really difficult to host an application. GDRP, everybody has known about this? Yes? In US also? Okay, thank you. So it's a General Data Protection Regulation. It's very important because you cannot store, you cannot collect all the things you want, and you cannot also store all the data you want. And if you store some data, you have to store it and encrypt it. Okay, it's very, very strict in our country. So what does it do? So it's a regulation, something. And that's also a right for people to come back and say, I don't want you to get my data, I want to withdraw my data. And it's also something good for a company like us, because we need to be more strict on how we store the data. Immediate consequences. For example, some of our customers required us to encrypt the virtual machine. So just before we talk about sometimes virtual machine is slow, believe me, if you encrypt your virtual machine, it becomes even slower. So impact on performance. We need also to encrypt cold storage. That's something. So for example, we use PG crypto, it's very easy. And also we need to secure the Docker image. That's why we are running Kata container. Okay. So Kata container, just to turn your standard deployment to a Kata container, how do we do? That's the summary. We install Kata container, we configure Docker, and we run the Kata container. It's very easy. It's done in a few hours or less. Some of you already moved their container to a Kata container in this room. You never tried? Okay, I hope after this presentation you will try, because it's really easy. Okay, don't be scared. You've got somebody here who can help you. I know this girl, I heard before, she told to all of you, if you have a problem, contact me and I will redirect to the right person. Okay, and she agreed. But it's so easy. How do you do? So this slide, you saw it before, huh? More or less the same one, except that this one is in the good direction, not like yours. Sorry. So why use Kata container? To enhance security. with virtual machine isolation. It's compliant with Docker, and it's ideal for sensitive workload, which means easy to deploy on the cloud. What you need, a Linux host, an hypervisor, so she mentioned just before about some hypervisor, and a container runtime. Example of installation, it's so easy. You just need to move your Docker configuration file to reference the Kata container, restart, and that's all. Okay, so for those of you who were scared to move to Kata container, so easy. Okay? Do you have question about this?
You answered the question I asked.
Okay, great. It's better. If you want right answer, ask to her. Exactly. And you know, because of the man before, now I'm streaming. She was not streaming, but now I am. Okay? It's my first stream. So honestly, it's very easy. And the result is great because you are running it with an isolation level, okay, which secure all your virtual machine.
Can I ask one more question? Will it run on OpenStack laptops?
Up to you. Okay, I will not try. So some example of now what we run on Kata container. We have an open data platform. Some of you have heard about SCaLE? SCaLE or SCaLE? Yes, no? I saw some people moving their head, not raising their hand, but it's okay. So we built an application using Drupal and SCaLE, basically, plus some other things. So, for example, here you can, maybe you can see OpenInfra, scikit-learn, Jupyter, Python. And what does it do, this application? You can just collect open data and you display the open data on your portal. Open data is also a law in France and a law in another country, which said that as a public citizen, you pay your bills, okay? So you need to have a view on what your administration do with the money. So that's where open data comes. Okay, so with this you can access to many and many websites and look at the data. So that's how we built our application. So here you've got some standard Docker component that after run on Kata. You can see, I'm certain most of those components you know this, you've heard about this. And about LLM, we use either, here it's Llama, but we use also OpenIA, it's more or less the same. We use the generation is almost the same, so there's no problem. And we use it to do some subjects, so I will demo, it's much better. And this is what we can have using the OpenIA generation. So you can have all those things, just writing some natural languages sentences. This is what is behind. So I will show you some demo. For example, if you have an API that will send you some data, you just do ask the application to enter here's the API, and then it will turn it into a dashboard. So how will the process works? It takes the data, it analyzes the data with some components, and then after, this is an LLM generation. We give him a JSON file, and he will create the same kind of JSON file with some data here, okay? That's the first step. The second step with this is we have a prompt, which is a IA prompt. And with this prompt, it will run a statistical analysis of some data. So for example, to build this kind of dashboard, which better you need maybe 2 or 3 days, now we can build it in 5 minutes. Okay, so this one I will demo. I've got 3 or 4 demo. What you will see. So you connect to the application, you ask to do a new dashboard, It's very easy. You just create and you just enter information. So maybe it's too small in the screen, but you just said, I want an API as a data source. Oops. So then after, there is some process. So the application is just getting the data, analyzing the data. That's where he's asking to scikit-learn to, for example, give a type to every data. Is there some access? Is there geolocalization data? So he's just analyzing the data. And once he has analyzed the data, he will try to do some cross-tabulation, some simple graphic or something like this. Okay? So all this process is really, it's real time. I did not cut the movie. So it gives you a dashboard like this in 2 minutes, let's say. And you have this with a map. So the maps is not really centered, but it's not a problem. You center it after, and you have this kind of slide. And once you have done this, you can call another assistant. I think it's just before, later. Okay, you need to store your data, your dashboard. That's it. There is some parameters, I'm sorry. Okay. And from there, after, I will just add a prompt. I mean, it's like a standard prompt here. I just choose the graphic I want to analyze. And there will be another component that will now generate a text. So it can be, here it's in French, sorry. So I think in this room, maybe only 2 or 3 people can read the French, but it can be in English, it's just a configuration. So it just analyzes the data and it gives you this kind of analysis of the data itself. It's just statistical description of the data. That's it. And from there, you've got your dashboard, and it's available like this in 2 minutes on the web. Okay, so that's the kind of things you can do now with data, modern application, and LLM and our application Data for Citizen. So from this, there is some functions to change the layout of the data. There's many things like this. I still have 10 minutes, it's perfect.
Can I ask a question? So I saw the OpenAI symbol there. So are you using the OpenAI model for analyzing the data?
Sorry?
I saw the OpenAI symbol on your slide.
Yes.
Are you using OpenAI model?
Yes. We use OpenAI API just to generate the dashboard. That's it.
Then you could ask it to translate from French to English as well.
Yes. Yes, you can. There is another sample. You know, I've got 6 or 7 movies, but it's I don't have the time to display everything. But some is in English, some are in French. Okay, it's so easy. Just a configuration of your browser, and when you call the API, you just ask him in which languages you want the return. Okay. So that's one of the things you can have. Another kind of very famous one, which is the iris tree. Okay, thank you. I've got 2 minutes additional, I think. Sorry. Thank you. So that's the kind. Some of you knows this kind of decision tree? Yes? No? Okay, in analytics, it's very easy. So we embed this also. I've got a movie on this. And what can be nice is this one. So I will more demo this one, which is better. Okay. Okay. So when you connect on the data, I will demo you two movies. The first one is you just discuss with the data, which is also something interesting. So you connect to a data file. For example, the data file you just import. And from this, you will just write simple sentences. Here I just ask for a 1 2 day, a simple graph. I think this one is just a single graph. It's antenna, you know, radio antenna. So I ask for a graph with a different generation, and it will just send you back the result. So, and it works in any languages. To ask you, we test it in English, in Spanish, in German. It works. You can ask any kind of languages. Okay. So after this, I ask another question, which is to have a 2D graph. So it will start again, and you just get the 2D graph like this. Okay, simple. And after, if you want this 2D graph, say, okay, now turn it into a 3D graph. So you just ask him, make a 3D graph, and he will generate a 3D graph very easily. So, and you just discuss with the machine, which is very interesting. Before this, you have to have a consultant, a BI consultant, and explain him what you want and something, and so you get the result. Okay. And last one, because I know my time is short, this one is about prediction. Oops, sorry. Oops. Okay, this one is a prediction. So I've got some data. I will go fast on this one. It's 2 minutes. Yes, thank you. So I can demo over one. That's why I told to the girl I need 2 additional minutes. Okay. And if some of you have time, I can demo it real time on a website, and you can ask questions in any languages, but you need to wait the internet to answer. So on this one, I just ask, do a graph by year, okay? And after, because here you've got many different years, 2020, 24, I ask, can you do a prediction to 2025? And it will take the data. Here you've got like 700,000 data. Okay, so we've got an interesting number of data, and he answers you the result for 2025, sorry. And so after this, I said, okay, but now this prediction, I want it in the graph from the color orange. So he will rewrite the graph that you saw before and add another year, which is a prediction year, and it's in orange because I asked it to do it in orange. Okay? And I'm just talking with the machine. That's the interesting things. Okay. Another one, because this is something which was really difficult to do for all of you, and for me also. You have your file, and okay, you want to have a standard graph, so I ask a standard graph, and after you want to apply a filter on this graph. Okay, so just like this, you will first get the standard 2D graph here. And after, I just ask the machine, can you add a filter by status or something like this? And it will just ask a list box on it, so you can apply your filter. And all this can be turned into a dashboard. I will show you after. So now, after the generation, so with this you can play with any kind of data. So if you've got a small warning, but it's running perfectly. You got it. Oops. Oops. And this is what you can do at the end. All this can be deployed in a dashboard. Okay, so from, let's say, we downsize the time to create a dashboard to 3 to 5 days to like 1 or 2 hours, using really OpenIA API, OpenIA LLM generation, and scikit-learn to do the data analysis. And you can ask this kind of graph. He will do it without any problem. If your data are geolocalized, you can ask him create a map it will create a map. Here, like this one. Okay, it's very easy. You can have 3D graph. You can have also, I've got this one. I ask him, I will go at the end of the movie on this one direct. From this one, I just ask him to do a 3D graph, but 3D graph interactive. Because it's better. Now it's virtual, you know. You turn this one. Oops, no, sorry, it's not this one. Interactive is this one. Oops, like this. See, you have this. It's very easy. And it's running on internet. You can deploy your visualization in any dashboard and send it to anybody. That's it. So that's other example. So that's another. All this is running behind in a Jupyter notebook. So you can reuse all your code. Okay, there's no problem on this. I will maybe try to show one if internet is okay. So that you can see the code behind. Oops, sorry. Okay. It looks like it's running fast, so I'm happy. I will go on this one. So if I go there, 1 hour ago it was very slow. Now I'm done. It will be a little fast. So here it's working, you know. It's getting you the result. And here you've got the code, if you want. If you are a Python developer, you can view the code, or you can open your code in a Jupyter notebook. Okay, or save your code and put it in a dashboard. There's no problem. Okay, so we got the Jupyter notebook here, and from Jupyter, for those who know, some of you are using Jupyter. Okay, perfect. For this, we have a Jupyter connection, so I can connect to any kind of data directly from here, and view lots of data here. Choose my data, choose the column, and analyze it. So it's very easy, and each time I have this, I can after use it, in my application from here. All this one, for example, this analyze, I will call it ZZZZZ, okay, like this, because it's real time. And now if I go in my dashboard, I'm sorry, dashboard is this one. I will create a new dashboard, and from this, I can always take my Python analysis and take this one and put it in my dashboard here. And it will just run and ready, and you can add some KPI indicators, maps, anything. I just have to size it good, and it's running. Okay? So we're lucky because we saw some real-time development. Do you have some question?
Yeah. Do you use the Python modules like LangChain?
Yes, we use it. So I demo for you. When we are here, we have here, that's a LangChain one, which allow you to connect to different database, find the relation between the table, and get the result. For this presentation, I just connect to one table and one data file, but it can be multiple one.
Did you employ any AI agents in this?
Yes.
Okay.
And it's running pretty well.
Okay. And you use the OpenAI API when you call it?
Exactly. We moved to OpenAI 4, I think. And we are running Kata 3.10 or 11. I don't know. I think the last one is 14 or something that you tell, but yes. Yes, question?
Yes, you mentioned
Basically, for GDPR, the problem is with information like name, telephone, email address, everything that can allow somebody to detect and identify yourself. And all this, we need to store all this information in a crypto way. So you need to encrypt all your data. We have an agent that look into any file if there is some GDPR potential data. And when we find it, that's in our application, when we find the data, we just prevent the data file to be published. And we ask somebody else to review the data file. Can be a data file or can be a document, a PDF document. So we do OCR on it, and we try to detect anything that looks like personal information. That's a lot of work. That's
Why don't you use Llama 3.2 on your desktop? Then you are not exposing training.
no.
Llama doesn't do a good job.
I don't think so. Do you have any question? Sorry. No? Thank you very much.
Okay, thank you, Patrick. After Patrick's great talk, we have a break, and we will be back at 4:30. So, see you all then. Thanks.
That one's okay. Hello. Okay.
It's running this one also.
Yeah.
Good luck. Are you around tomorrow? Yes, I'm around. With my wife. And the deal to come here was tomorrow morning. We are tomorrow. But I'm not today. I can be here tomorrow afternoon. But in the morning, I go to difficult to have.
Okay, how does this work?
So,
Ah,
this and this, I think.
okay. All right, let's see. Let's try.
That's how it's supposed to work.
Because I will need to advance it here.
If you have your slideshow, it should work. But make sure you're pointing.
No, it doesn't.
Is it working?
No.
Can I try it?
Because the clicker will need to talk to the laptop. There's usually something that talks to the laptop.
Hi, everyone. We have today Mr. Ken Crandall, and he's going to be discussing the economics of migrating from VMware to OpenStack. Take it away.
Use the mic. I asked for it. All right, can everyone hear me now? All right, cool. So I'll start over. My name's Ken Crandall. I am a product manager working on our OpenStack releases. I've worked with OpenStack since the Essex and Folsom days, so quite a while. I'm an 8.5-year racker. I've been at Rackspace the entire time focusing on OpenStack. For 7.5 years, I was a subject matter expert solution architect for OpenStack, and now I'm part of the OpenStack business unit. So what I'm here to talk to you today about is obviously the economics of migrating from VMware to OpenStack, and it's based on real-world numbers that we've put together across several customers we've talked to around the world. So quick introduction, I'll give kind of about the nature of the talk. Then we'll talk about understanding the cost structure of how we're actually going to compare these things. I'll go into some case studies, about 3 of them to be exact, and then we'll talk about some alternative approaches because having a standardized methodology and running through case studies is great, but often just by changing one little bit of it, we can see some massively different outcomes. And then we'll wrap up, and if time permitting, I'll answer questions. If not, I'll happy to answer them after the talk. So things I'm not going to talk about today. I'm not going to talk about OpenStack migration processes. There's plenty of vendors here who have tooling and methodologies. We have our own tooling and methodologies to do this stuff, so I'm not going to talk about that. Another thing I'm not going to talk about today is a feature-by-feature blowdown between VMware and OpenStack. Again, this is something I talk about a lot with customers, but it's really more what I want to focus on is the numbers behind why you're going to do this. Real quick, one of the things I ask customers is, how much of a premium would you put on your freedom to be away, to be not underneath the boot of a vendor? Because we kind of, especially with open source, we take it for granted that we have control over our own destiny and be able to do the things we want to do without necessarily being beholden to a vendor's licensing regime. But even more importantly, what if I told you that vendor, we can essentially pay you to do the same thing. So not only can you get out of that particular trap, but you can also save money while doing it. So the question is, what goes into the cost that we're going to be looking at? How much does it actually cost to do a migration? What different migration strategies are we going to look at? What are, I'll give you some examples, and then we'll talk a little bit about what you can do with those cost savings. So the question then is what to start with. Do we look at the operating costs? Do we look at licensing costs, support, switching costs, so training and migration? Do we look at modernizing applications, upgrading our platforms and infrastructure? All of these things would be potentially good options to add in there. But what we're going to do is kind of narrow it down a little bit. But before we do that, I want to talk a little bit about how these two things have different cost structures. It's not quite as simple as being able to say, this apple is 50 cents, and this orange is 25 cents, because you're talking about apples and oranges. So the cost structure of OpenStack is different, and depending on the partner you have to work with OpenStack, the licensing and cost structure and support costs may be wildly different. I'm going to speak from Rackspace's perspective, of course. We use 100% OpenStack distribution where there's no software licensing costs or subscriptions. So essentially the licensing cost is 0. Secondly, our costs are based around the number of hosts that are supported part of our managed service, which is 24/7 by 365, fully managed. Now on the VMware side, we're all pretty familiar that there is some kind of licensing fee with that. The cost structure of VMware actually changed kind of significantly when Broadcom acquired them. They have a much more consolidated pricing view now, and it went from a kind of a more a la carte model where you can pick and choose the features and levels of support and the number of sockets you wanted to, or cores you wanted to license, what features you wanted, and so forth, to much more bundled subscription-based pricing model. There are still lower priced offerings, but what they've done is put some restrictions around those to try and force most people to the VCF and VVF pricing bundles. So that's VMware Cloud Foundation and VMware Virtualization Foundation, I think those stand for. While there is some nominal ability to file support cases for bugs or for help, a lot of that depends on the partner they're actually acquiring vSphere from. So if they're acquiring it from Broadcom directly, that's whatever program they have. If they're going through a partner, it's whatever services that partner bundles with vSphere. So now that we kind of see how these two things differ a little bit, let's figure out what goes into measuring the costs. Now, the first thing I'm going to say is, obviously, when we want to put the cloud operating system, so OpenStack or VMware. Second, if we're going to do a migration, it's only fair to incorporate the switching costs into your calculations. So the cost of migrating it, whether it's done by tooling or by hand. And then we're going to do something a little bit audacious and say we're going to reuse exactly the same hardware in our final OpenStack decision as we did from the beginning of VMware. And while this is not necessarily what you might want to do, it's only a way to make it fair. Because if we're going to compare apples to oranges enough, we're keeping them as similar as possible is kind of important. Things we're not going to include: application modernization, workload consolidation or refactoring, or infrastructure or hardware upgrades. I'll come back and talk about those in a little bit, but they're not going to be part of this model that we're using to compare these two solutions. So now that we've kind of built our model, let's look at a couple of case studies. First is these have been anonymized, so I'm not actually talking about which customer or they refer to. I'll leave it to the rackers to try and guess who they are. And this is what I call the small deployment. Now, you might say 40 hypervisors isn't exactly a small deployment. Well, in the enterprise scale, it is. We're talking pretty much at pretty decent scales now. If you've got somebody who's only got 5 hypervisors or 10 hypervisors, they could definitely deploy OpenStack. We have models for doing that, but that's almost really, you're going to buy new hardware and build a new one next to that and then decommission the old one. You're not going to really look at migrating. So for this small deployment, we have 40 hosts on one site with 680 virtual machines and about 1,280 cores that are being licensed. Now, the migration strategy is going to be close for all the different ones. We're going to migrate 100% of the VMware to OpenStack. When we start, we're going to start on whatever day one of that migration timing is that the customers decided. And then we're going to try and normalize the rate of migrations to about 10 ESI hosts a month and about 200 VMs a month. So the cost for this customer, when they started, their VMware cost was about $384,000 a year. The ending operational costs for OpenStack were $134,000, almost $135,000 a year, and the migration costs were $68,000. Now, what does that look like? Well, the graph kind of shows the numbers month by month, but what's important is looking at the total yearly costs. Now, again, year 1 and year 3 are pretty easy to understand because you're starting at 100% VMware and you're ending at 100% OpenStack. What's really interesting is that middle year. Now, in this case, for this customer, they have incorporated all of their migration into about 6 months. So that 10 hosts a month, that was 200 VMs a month, that was more or less the rate of a certain number of individuals working on that with a certain amount of tooling. And for the migrations, I basically used a pretty typical 70-30 ratio that we find, which is 70% are going to be done through some kind of automated tooling or fashion, and 30% are going to be kind of white glove, lifted and shifted by a human. So year 2 is really interesting because not only is there a gradual drawdown of VMware and a gradual buildup of OpenStack, but also there's all those migration costs. And you notice that year 2 is still significantly less than the first year. In fact, and where they end up is with a 65% reduction in operating costs. So while you can say, yes, VMware is 65% more expensive than running OpenStack, you're also saving money during your migration. So look at a second case study. This is not a whole lot bigger, 60 hosts versus 40, but it's across 2 sites. So it adds a decent level of complexity. There's fewer larger virtual machines, and again, about 1,280 cores of license. And again, this is actually a little bit slower. They're planning to do 5 ESXi hosts a month and 100 VMs a month. Now these are bigger VMs, so part of the reason that the rates are lower is just physics. When you're moving larger VMs from one environment to another, it takes more time. So you can see this spreads out almost doubles the length of time that the customer is migrating. But you'll notice their year one costs are $864,000 to run VMware. Their year two costs for all the migrations are about $700,000. But year three, when they're 100% OpenStack, goes down by almost 75%, back to 76%. So again, a significant reduction in operating costs. Now again, these are best case scenarios where you're 100% going from VMware to 100% OpenStack. And again, these migrations are, again, best case scenarios at a very regular rate. Now what you're gonna find if you do this in reality is they're gonna be much more stair-steppy and much more, you're gonna find you can migrate a bunch of VMs at one point, and then you'll be slower as you migrate a fewer bigger ones. But we've just linearized these to make the numbers a little bit easier to understand. And then third case study. This is a large deployment. 16 sites, 325 hosts, 7,400 virtual machines, and over 10,000 cores. Now this is almost a worst case solution for OpenStack, at least for us, because for this particular customer environment, we're looking at doing a control plane at each one of the 16 sites. We're not doing any kind of stretch cluster or anything out. And that actually hurts us in the sense that there's a larger number of controller nodes that are being used that are not part of running workloads. And also slows down the time it takes to build it out. Additionally, this customer wanted to do the entire drawdown over 3 years. So again, it gives a lot different of a viewpoint. You can see it's a much more gradual drawdown and a much more gradual buildup. But you can see 46% reduction costs overall from, again, a 100% VMware to 100% OpenStack. So even again, you're going to be realizing this over 3 years, you're almost reducing your operating costs by, you are reducing your operating costs by over half. Now all of these approaches assume kind of the same thing. One was 100% VMware to 100% OpenStack. Second is, what if you're actually going to do a gradual drawdown of VMware and a gradual buildup of OpenStack? So what if we take kind of case study 2 and look at it a little differently? What if the customer stopped licensing VMware on day 1 of the migration? Now this might seem like a kind of absurd use case, but actually we talked to quite a bit of customers who are already consuming VMware a little bit differently. They bought perpetual licenses. They're not consuming it as a service. So for them, they would actually have to buy new licenses. And so for them, they're actually out of compliance because those licenses got canceled, and they're choosing to not renew them or not buy the new ones. So this kind of drastically changes the economics. So you can see year 1 is still $864,000, but year 2 is $291,000. So again, you're still bearing the full cost of that migration in year 2. And then year 3 is $207,000. So not only do you see the 76% reduction for year 3, you still see a 66% reduction in year 2. Now, there is greater risk, right? Because you are operating some of your environment over in an unsupported state. But this also assumes that, hey, let's draw up OpenStack rather quickly, so maybe we're going to invest in new hardware. And again, if you're saving 66% in year 2, you could probably afford to replace your entirety of hardware pretty easily. So I kind of, and if you have that $570,000 roughly savings in year 2, not only can you replace your hardware, but why would you replace it like for like? You would probably be buying higher core count CPUs. You would probably be buying larger RAM. In general, you'd be buying bigger boxes. So bigger boxes, those numbers, like I said, are predicated on going from the same hardware to the same hardware. But now if you're basically, let's say you're replacing that hardware with roughly 2-to-1, 3-to-1, even 4-to-1 scale, you can cut down the number of hosts under management. Because remember, from Rackspace's perspective, a host is a host is a host. It doesn't matter if it's got, 2 sockets of 24 cores each or 1 socket of 244 cores. It's still a host, even though that second one is 2 to 3 times as dense. So that could end up lowering your year 3 costs even further. The second alternative approach is what happens if you can't migrate the entirety of your VMware? What if, that might not be a realistic outcome. So I split the difference and said, what if we left it 50-50? What if you just migrated half of your VMware estate to OpenStack? Now, the savings aren't nearly as great. And year 2 is still pretty expensive. That should show you just how expensive it is to operate VMware. Because even cutting it by half, even VMware operation costs by half, you still have to do the migration of the half you are. Migration isn't cheap. It's certainly not the $5,000 a VM number that's been thrown out. And incidentally, if anyone wants to do that, I'm happy to take that job. I'll do 1 VM a day. That means I'll make $1.3 million in a year, not even working nights and weekends. That's 4 FTEs. And if each one of those people can actually move 1 VM a year, that number just doesn't add up. So even though you're migrating half, it's still a 26% reduction in operating costs. Now, you'd like to see it be higher, but at the same time, that should just, again, show you how expensive that VMware actually is. So even though you're doing a partial migration, you can still have a noticeable high double-digit savings in operating costs. And even bearing the full migration cost in year 2, that's still a 6% savings over your original I do nothing cost. Now, another way to save money and keep that migration cost lower is what if fewer VMs need to be migrated? What if you could just redeploy? If you're deploying through a CI/CD pipeline, or you have, Ansible or Terraform runbooks to deploy your applications, just to redeploy them on your new host. Run through your DR process. Run through your backup and restore process. You don't actually have to lift and shift those VMs. That's a very expensive way to do it. And yes, that's a way to guarantee that you're running at the same endpoint, the same situation as you're running the start. But in a lot of ways, if you solve those business problems already, there's probably a faster and more economic way to get from where you started to where you want to be. So, just to wrap things up a little bit, open source is cheaper in many ways. Like we showed that not only is it less expensive to operate, but migration itself, even bearing the full cost of that, can yield significant savings. And the reduction of those operating costs is significant enough to absorb the cost of migration. There are many avenues to savings. Whether you're doing a full migration or a partial migration, you're going to save money. VM migrations can be expensive, but again, if you're not having to migrate everything, you can probably find less expensive ways to make that happen. And finally, repurposing that IT budget that you've displaced by doing the migration can accelerate other things that you want to do as part of your IT operating. So remember earlier I said we're not going to be doing app modernization or workload consolidation or hardware upgrading. But if you're saving tens or hundreds of thousands of dollars a year, then you can start bringing those projects into the fold again. And again, that gets you, if you have a multi-year IT roadmap of where you want to be versus where you are today, just by making the change of what's cloud operating system you're running on, can really enable you to get there faster. And I'll leave you with this. When I talked earlier about not only going to newer hardware that's more dense and can replace fewer hosts, a lot of people who built large-scale VMware operating environments bought their hardware, and I would say that are license optimized for VMware. So they bought certain sizes of CPU SKUs, certain amount of RAM on host to avoid paying higher tiers of licensing costs. So you essentially made concessions to your environment to be able to optimize your licensing costs for VMware. What if you didn't have to worry about that anymore? So I threw a lot of numbers at you guys, threw a lot of options and things to think about to you guys. And if you have any questions, I'm happy to take them. Yes?
So, I really like this. We're in the process of trying to get VMware out.
Yep.
They're just breaking us over the soul. The perception at my leadership level is that the skill set is more expensive to have someone that's
that's actually a very good point. And something I talked with my boss about with last week. I would say that on the surface, if you're going to acquire new talent, then yes, it's harder to find OpenStack talent than it is VMware talent today. But I say that people who are good at doing and managing their cloud, there's always going to be people who have a skill set and that's all that they understand. If you go back to, I obviously have a gray beard. If you go back to the Unix to Linux migrations from 20, 25 years ago, there are a lot of people like, I just know HPUX, I just know Solaris. But they found out real fast, a lot of those skills were very transferable to running Linux, but they just had some blinders on because it wasn't familiar and wasn't what they were used to. Now, a lot of people running VMware today can pick up the concepts of running OpenStack pretty quickly. And in fact, depending on how you want to run OpenStack, you can operate in a very similar way to VMware. So a lot of the concepts they have will translate over. And so yes, there is going to be a cost to retraining them, and that should definitely be built into your switching costs. But I don't think that, literally, unless you're going to wipe out your staff and rehire a new staff, anyone who already understands kind of how clouds work, how virtualization works, it's not quite the same as going from bare metal virtualization where you had people who were really specialized in compute, really specialized in storage, really specialized in network. You already have kind of multifaceted people who understand all of those different domains. That's really the big jump in skill set. It's just learning, same thing would happen if you ran Nutanix or you're switching, some other thing. You're going to have to learn a new tool and domain. But again, a lot of those skills are transferable, and it's just more like learning the lingo and learning where to find the answers to your information. Any more questions? So I guess I'm giving you all 5 minutes back. If you think of any questions or anything else, find me. I'll be at the Rackspace desk most of the rest of today and tomorrow. Otherwise, thank you very much.
Hey everyone, we have about 5 more minutes till Ken Tan takes center stage. So please stay tuned. Thank you.
Matthew, where are you?
Good afternoon, everyone. Thank you for joining us for the final stretch. Today we have Mr. Kenneth Tan, and he will be discussing preparing VMware systems for OpenStack migration. So take it away, Kenneth.
Good afternoon. Hi. So today I want to talk to you about VMware to OpenStack migration. So now we're going to go through 5 major topics, and we can look at them as the considerations that need to go in when we're talking about migration, what are the planning points, and how do we test, and how to automate, and then we'll look at, finally, a example case. Yeah? So, let's get started. General migration considerations. So, migration from VMware to OpenStack, yes, it is a significant shift. And it's significant from a technical standpoint, from an operational standpoint, as well as an organizational standpoint. And the migration issue is perhaps not just a technical matter. The human side is very, very, very important. So it's really human factor, human factor, human factor. And we'll see this theme all the way throughout. So, and in a way, VMware migration, this is like a project not too dissimilar from many others. It's a large part of it is the human aspect of such projects, which is particularly poignant when we're dealing with something that's been there for a long, 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 long time. And the system, the migration project will become even more difficult, even more challenging, if not everyone in the organization is on board. And now, let's take a look at an example. Some key differences. So VMware allows very, very flexible VM definition at the point of creation of the VM. But OpenStack doesn't let you do that. OpenStack defines templates, defines flavors, away you go. You don't like that? Your problem. Size up or size down. And VMware deployments, typically, they have integrated backup solutions, whether you use Veeam, use Acronis, or something else. And those kinds of tools, they've been there. They've been there for ages. OpenStack doesn't have that. With OpenStack, you want to back up? Oh, yes, there is backup. But they are additional. Okay? And then, VMware, it's one single console, and there you go. Fairly simple. OpenStack, oh, you scratch your head, and you see, there's Linux underneath. Right, what is that monster down there called Linux? How do I live with it? Do I have to deal with it? And worse, there is this strange thing, Alma Linux, and there's another strange thing, Ubuntu. Good God. How many more flavors of this monster could I possibly get? And, well, VMware, you want a self-service model? Yeah, there's VCF, but not all sites use VCF. So, in fact, I know of a number of large banks. The workflow for a development team getting a VM is actually create a Jira ticket. That Jira ticket gets assigned to somebody in the infrastructure team. The infrastructure team then passes the ticket to the Windows team because VMware is run by the Windows team. The Windows team creates the VM and see, oh, this is a Linux VM, not my business. They pass that VM to the Linux Unix team. The Linux Unix team sees, aha, now I have a VM, I'll get an instance of Linux on there, and flow back. That whole process, if you're lucky, a week. If you're unlucky, 3 weeks. If you messed up somewhere along the way, like specifying the wrong VLAN, start from beginning. And does the user have any way of creating a VM themselves? No. But that's the organizational process. Whereas you look at OpenStack, it's all self-serviced. You want to create a VM? Sure, go, point, click. 30 seconds later, you got a VM. It's a very different operations model. Yeah? And so, how do you structure a process? And as we've seen, VMware, you got to deal, in planning that process, you got to deal with a lot of history. Ancient is not necessarily the right term to use. It's just, it's been around, right? And that also means that some VMs have been around for a long time too. And when you look at what the client's doing, the client may want to continue using the tools that they have been using for a long time too. They've paid for the tools. They have people who are skilled in those tools, and that's also cost. And how do you deal with this? How do we allow the organizations to maximize their investment? Could we? And within the organization, there's also a lot of knowledge, a lot of established behaviors. So that means you're going to see a lot of, I don't know why, but I've always done it this way. And when it comes to people and organizations, you're going to see also a lot of vested interest, and the vested interest may go in all sorts of different directions. And these factors, they're actually not necessarily unreasonable. Very often they're quite logical. Yeah? So, Windows 98, anyone? This actually came up recently at a manufacturing firm. The manufacturing firm uses Windows 98 to manage a certain piece of machinery. That machinery goes in, and it needs to run for 30 years. So you work it out, Windows 98. That's not even 30 years yet. So now, what do you tell the client? Very sorry, dear customer. Why the hell have you not upgraded your Windows 98? That's not what you could say. If we have time, I'll come back and explain later the considerations of this particular client at the end. Okay? So, if we look ahead, as part of this project, we need to implement a new system, right? Because we're going to migrate from VMware to OpenStack. So we need to implement a new system. And with that, you get fear. People are afraid. It's something new. It's a new step. That's natural. We can't discount that. And then if we look at the more technical factors on the network, do we reuse the do we reuse the IP? Do we not? If we reuse the IP, you need to do a little bit of planning, yeah? And if you don't reuse the IP, oh geez, those VMs have been there for how many years? Is anybody going to be sure that there is no hard coding of any IP address anywhere? Do you want to find out the hard way? Perhaps not. Yeah? And what about storage? Can we use, does the customer want to reuse any existing storage? And if so, how to integrate the storage system into OpenStack? What does it support? And, I mean, what does the storage system support? And does that storage system have any drivers in OpenStack side? So, does that mean that when we implement the integration with the new system, we need to talk to it using iSCSI, we need to talk to it through Fiber Channel, NVMe over Fabrics if it's a newer one, or we turn the whole lot into good old NFS and run it as NFS. Maybe so. But that also comes down to what do we have, what can we do, what does the customer want to do with it. And invariably, at some point, we'll come to this question of downtime. So, the issue of downtime, we need to understand how long that downtime could be, would need to be, the order of the migration, and when. And no, if you get the infrastructure team to say, we will migrate on 1st of January, it doesn't mean that the application owners are going to agree it will be 1st of January. So this goes back to what I was saying earlier about divergent interests. And the VM has been there for a very, very, very long time. Right. The application owners are not even confident that the application will come back up even after a simple reboot. Oh, geez. And that, by the way, was the case at a bank, which shall remain nameless. And yes, it's 2025. So now then when we look at data transfer, if we could get the client to go get rid of data that they don't need, we are in a better position because it helps reduce the amount of downtime and get us to migrate quicker. So when we're talking about data transfer, let's look at some math. Ideal situation, a 10 gig network will transfer 1.25 gigabytes per second. 60 seconds a minute, 60 minutes an hour. So that means 4,500 gigs per hour. Yes? Logical, right? Uh-oh. But don't be surprised if a customer says, no, that's too slow. So what are you going to say? And got to go back and explain. Unfortunately, that's the constraint that we've got to work in. And then you get some smart aleck that comes along and say, let's do incremental transfers. Okay, exactly how would that work? Right. Good old VMware has this thing, a network block device, and you do the concept is you do the big chunk first, and then you do incrementals later. And there are some players in the market that would say, yeah, we do that. Is it a smart idea? Maybe, maybe so. Because that NBD client, don't be surprised if it's not too reliable. So if you want, that is a way. So, dear customer, what would you like to do? You want it quick, but you may not necessarily get all the data there. And you don't know whether a certain bit of data doesn't get there. You hope that it gets there. You don't know for sure. Or do you want to turn off the VM, shut it down, and we can be sure the data gets there. No data loss. So my recommended approach is that we want the certainty of no data loss for the customer. So if a customer asks, what do? Shut it down. And what's more, the transformation step is only done on a copy of the VM. The original VM is never touched. So we can always roll back on the VMware side if ever needed. Okay? And this is a OpenStack related event. And quite a few of you are familiar with OpenStack. So I'm going to say there's no room for OpenStack nonsense. What is this nonsense that I'm talking about? First, long deployment lead times is not in the interest of client. And second, after the system is implemented, after the system goes live, the customer is the one who has to live with that system. And if the customer has to live with the system, the customer needs ops tools. So that means, as a supplier, the ops tools need to be there. You need to make sure the ops tools are there on day one. And it is really a dumb idea to make that yet another consulting opportunity. And with regard to migration, the whole thing should be based on tools. There are people who would say, oh yeah, let's do the whole migration as a consulting project. Let's see. How is that interest going to align with the interest of the client? Because the client wants to get the job done quick, wants to get the job done at a known price. But the consultant wants to make the whole project as long as possible, ideally infinity, never finish. And also remember that for the client, being product-driven doesn't mean that it cannot come with services. It cannot come with assistance. It can. It just needs to be product-led, not consulting-led, right? And then, at some point in the future, the system will have to be upgraded. No, this is not going to be yet another beginning of a new ancient thing, however many years down the line. We need to think about how things would be upgraded and know that upgrade step should not be turned into yet another never-ending consulting project. So, how do we ensure migration works, migration gets done properly? We need to make sure that there are VMs that we could test, and then we trigger the migration. We could trigger the migration in several chunks of the VMs or a whole set of VMs. We can define how many VMs we want to transfer. And the transformation step happens in between, and that happens with the copy of the VMs, not the origin VM. Yeah? And then we check that, yes, it works properly. So, with this, we can get some realistic timing, both on the network side, on the hardware performance side. And going further into estimating migration time, this is really to understand the bottleneck, whether it's the connection between the VMware system and the storage backend, and also get to understand what's the link between the VMware system and the migration worker node. And this is to read out the VM, and then once we've transformed, we've got the same thing now, but in the other direction, writing it into the OpenStack system, writing into the storage system there. And the VM size, and thus the amount of data to be written, would be a factor. And then, when we look at VMware, there's a lot of Windows. On the Windows side, we need the VirtIO drivers, and luckily we have the VirtIO Windows driver packaging, and there are scripts to do so that helps us create the transformation step. So, some commonly encountered trouble. First off, as I mentioned, we need to have the VM shutdown. That's recommended. And then the length of time that it takes to transfer subject to network and storage performance. And some of the VMs, we may not need to migrate. Why? Because if they are already being fronted by some high availability load balancers, then we just deploy them fresh on the OpenStack side. Save time. And what we should also make sure is that if there is some network trouble, some storage trouble, we need to be able to re-trigger. And once we have migrated, we make sure that we can verify that the VM was migrated properly. And this is very important, that the client is involved in that step. Because you need to make sure that, again, interests are aligned. Then, if there's any trouble, because we only operated on a copy of the VM during the transformation and the subsequent migration to OpenStack, we can always roll back. Yeah. Now, what about the client's other expectations? Are there other expectations? So, one of the points that come up is site recovery. How do we do site recovery? Well, in OpenStack, surprise, surprise, we are having to deal with the differences between the operator and service consumer models. So, the operator is responsible for full system operation. Therefore, when it comes to site recovery, this is done from the operator's point of view, meaning the entire site is to be recovered, not per VM, full site. And there are benefits to doing so because we make sure that everything goes and there's nothing that needs to be done on the VM side to change IP or anything of that sort. Okay? And then, on the resource adjustment side, we can do disk resize easily, but what about VM, CPU, and memory? Can't be done. Not today. But can it be built? Yes. And what about resource optimization? What's the equivalent of VMware DRS? So that you can optimally pack VMs, optimize resources. And now I was told I can't do a product talk, but here's a hint. There is a reason why the company's name is called Sardina. Yeah? So what we do to get that going for the customer is that we build up systems in a Lego-like building blocks manner, specify the systems, and if the system is to be deployed in factory, we can do that, get the system deployed in customer site. Our usual approach is we say, yeah, we'll do it in 2 weeks, but I know also that if my guys take any more than a day to do the deployment, there's trouble somewhere, meaning I've built in 13 days buffer. Yeah? And then for the migration solution, we do it with a tool. It's called Fish or Move It. And the migration approach, we can do it on a per VM basis. We can do it for the full set or a subset. And we have a well-traveled path from conception all the way to production. Everything tools-based product. I'll skip through this, and we can look at an example case. This is a finance company in Indonesia. We worked with them to migrate the VMware workload recently, and they are one of the larger leasing players in Indonesia. So here, we help design the system, and then work with them to migrate the environment from VMware to OpenStack. So, some encounters. I've got a minute left. Yeah? So, Windows 98. Now, the situation is this. The manufacturing facility manufactures a certain product which is highly addictive. the manufacturing, sorry, that particular product is consumed by 50% of the population. And, or rather 50% of the population in that country. So, if you have a highly addictive product and the machine that manufactures it stop, the country has a problem. Yeah? And that's just a simple VMware migration problem, right? And here's another interesting one. It just has to be exactly like VMware, just cheaper. That's actually what I was told at another site initially. Thank you.
Thank you, Kenneth. Thank you, Kenneth. Now, please give us a few minutes. We are going to move on to our next speaker, who is Tony Breeds. So, thank you, everyone.
Okay. Oh, it's working.
Okay, awesome.
Nailed it. Only 6 minutes late. Off to a great start. So yeah, welcome to the moving authentication from a single provider to all the socials. I apologize for the clickbait title. We're not actually going to all the social media apps at all. We're just going to add one or two very heavily curated identity providers. Quick introduction. I'm Tony Breeds. I've been using Linux since 1992. My finger says I have no mail. That's a lie. Have no plan. That's definitely the truth. Today, I'm going to give you a little bit of a history of how we got into the state we're in with OpenDev, a little bit of a summary of the problem, what we want in the solution, what solutions we've considered, and where we're at. So how did we get here? Well, OpenStack's 15 years old, way back in the dim dark before I was using OpenStack for sure. We were using Launchpad for issues and specs and blueprints, and there was like a heavy involvement from the Ubuntu community. So Launchpad used Ubuntu One as its authentication provider, so it just kind of made sense for OpenStack to use the same one. Sorry, I'm going to take my glasses off because then I can actually see you and the screen at the same time, otherwise it was one or the other. I just want to make it clear, I should have started with this point, I'm talking about the OpenStack infra, or now OpenDev point of view. I'm not talking about end users or an OpenStack that you might deploy, but more the environment that the OpenInfra Foundation and OpenDev use to support OpenStack and other StarlingX, Zuul, other project development. So we were using Launchpad for issues and so forth, so we needed some form of identification for Gerrit as well, so hey, let's just use Ubuntu One. Nailed it. And then we added a wiki to the OpenInfra, the OpenDev services. Well, we're already using Ubuntu One for Gerrit and bugs, so we'll just use that. And we added Storyboard. Storyboard was intended to replace Launchpad for bugs and issue tracking, but we didn't quite get there. But we added a new service and we needed identity, so we just used Ubuntu One. Nailed it. Fast forward, hand wave, somewhere between 3 to 12 years, where we are now. Ubuntu One's no longer actively developed. It showed a great deal of promise. It was going to be a globally useful single sign-on provider, et cetera, but corporate direction changed, and that isn't the way it went. Ubuntu One originally started as an OpenID 1.0 provider. There was active development to get it to 2.0, but shortly thereafter, active development stopped. The OpenID Foundation took well appropriate feedback and sort of created this new OpenID Connect protocol, which is like the evolution essentially of OAuth 2, does authentication and authorization. OpenDev doesn't really want to be in the business of managing people's usernames and passwords. That's way more pressure than I'm prepared to deal with. I don't know about the other infra members, but yeah, no thank you. And OpenDev supports all of the OpenInfra Foundation level projects, you know, Zuul, StarlingX, OpenStack. Obviously we started with OpenStack, but we've grown from there. Kata Containers and Airship. So, where do we want to get to? Well, we want a solution where we have a single sign-on system for all of the OpenDev services. We want distinct realms specifically for Zuul tenants, but also other services would benefit from being able to isolate users from one realm to another. we don't want to actually have to manage the authentication credentials themselves. A few here and there for very good reasons is okay, but thousands for all of the developers is less okay. We have an identity provider, OpenInfra ID. It was called OpenStack ID, but obviously after OpenStack Foundation became the OpenInfra Foundation, everything gets rebranded for the good reasons. And we need to be able to migrate all of the existing services to it. Now, I've got Zuul in a question mark there because Zuul doesn't actually use, it uses an authentication provider, but it doesn't use Ubuntu One. And what we want it to look like from the end user point of view is you want to log into any OpenDev service, Gerrit, Wiki, Storyboard, anything else we deploy going forward. The service redirects you to our new authentication provider, which then gives you a choice. You can pick who you want to be identified by, and then you go through the authentication process there, and then you come back and you're logged into the new service, and all of that should happen without you having to recreate a user anywhere along the way. And bonus points if the identity provider can establish roles and group permissions and so forth to facilitate group management in the application level. So we had a couple of options. We could extend the OpenInfra ID. There's at least half a dozen different ways we could have gone down that path, but essentially we're trying to expand the OpenDev services to be less OpenStack specific, so the OpenInfra ID really came from the OpenStack roots, so it kind of felt like a backward step to be using that to say we're then agnostic, because lots of people don't have that account, so they'd have to be forced to create one. We could extend Ubuntu One, but as I said, that's no longer being actively developed, so we'd essentially be doing a private fork of it, and that's a lot of work, and we don't really want to do that either. We could write our own identity provider. Identity is tricky, security is tricky, hosting private data is tricky, so we don't have the time for that. So that leaves us pretty much with extend an existing IDP. And the ones we looked at were Epsilon, Dex, and Hydra, and Keycloak. And they were, actually none of them was a perfect fit. They were all broken or hard to use for different reasons. A couple of them looked really good. So, the plan. Pick an identity provider from the list that I just gave you. Add support for Ubuntu One or OpenStack ID, depending which one it supports and which one it doesn't support. Allow services to use this new identity provider. This is all rocket science, right? And then we wait, and we wait. And then we give users more time to migrate from Ubuntu One to the new identity provider. And then we nag the latecomers. And then we just turn off access to Ubuntu One. And anybody that hasn't done the migration, well, then we have a recovery path, but let's hope we don't have too many of those. And then we profit. Yay! So, this is the fun stuff. I apologize if I get ranty in here. Where we're at. Well, we settled on Keycloak as the identity provider, mostly because, I can't believe I'm going to say this, mostly because it's a monolithic Java application, and we actually have experience running monolithic Java applications through Gerrit, so it wasn't as scary as it could have been. Yep. And as a test, we set it up to authenticate Zuul admin and power users. So we're actually using Keycloak there as an OpenID Connect provider. And if you're one of these people, a Zuul admin or a Zuul power user, you can log in and you get extra features. Yay! And then we wrote a social plugin for Ubuntu One and added it to Keycloak. That's what I did for my Christmas break. Logins work. That's the hard part done. It's all downhill from here. I learned a lot about Java and container runtimes because that's how you got to test these things when you want, like, you've got your Keycloak service and your Gerrit service and your MediaWiki service. It's just easier to run them all in containers. Unfortunately, that wasn't the hard part. Learning new languages is fun, and Java is actually a new language for me. I mean, I did one university course in it a while ago. And yeah, I mean, I totally aced the iterating over command line arguments and printing out messages. Yay, hello world from blah, 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 blah. And that was as far as I got with Java. Turns out Java's come a long way since then. So I was essentially starting from scratch. It's fun, but it also sucks because you're like, how do I want to do something like a Python list interpolation. What's the Java equivalent? I don't know. You spend half an hour reading lots of different ways to do it and decide that none of them are what you want anyway. Containers are great, except when they don't contain what you want them to. You know, like trying to map user permissions so that you can like have config files outside of the container that are persistent, and you can have user data that persists across container restarts and all that sort of stuff. That gets a little bit fiddly. I mean, it's not impossible, but it's just way more work than I wanted to have to deal with. Documentation is fantastic, except when the thing you need to set is not documented anywhere, and you have to find it by grepping through source code, but you don't know what to grep for because you don't know what the thing is. Yeah. I have a patch to fix that, though. And then we get to the nitty-gritty, verifying the data you get back from Ubuntu One as an OpenID provider. I get the data back, and I know it's right because I can totally just read it. I know it's right. But when I try to verify it, I send the data back to Ubuntu One and say, this is good, right? You've checked my signature, I've checked your signature, you're checking my signature, it's good. They say, no, it's not good. I'm like, wow. And then I track that down to the fact that the OpenID library wants you to use exactly the same manager object for authenticating and verifying. And due to Java object lifecycles and the way Keycloak's implemented, that's kind of tricky. And you can't actually store the claims until you've verified them, and you need to be able to store that information, right? You need to be able to store the username, their full name, the nickname, time zone, whatever profile information you're getting from your identity provider, you want to be able to store it, but you can't store it unless you've verified it. I mean, I could, but that's not a very secure system, and despite being a bit hacky, I really would quite like it to be secure and production ready. And then mapping users is actually not as easy as you would like it to be. I mean, for the most part, a single user, like myself, I used the same email address everywhere, except where I didn't. And I set the same display name everywhere, except where I didn't. I did actually legitimately set my language to English everywhere, though, but that's not actually super helpful. So when you've logged into a service provider, MediaWiki or whatever, and it says your display name should be this, and then you log into Gerrit and it says your display name should be this, which one do you pick? You know that they're the same account because they share an email address, hopefully, but mapping the users so that people don't lose their change history or their open reviews or whatever, that's turned out to be a little bit more complicated than we would have liked. So, there's a slide missing. That's unfortunate. So yeah, I apologize again for getting you in here with a clickbait title and then not delivering on where I wanted to be. I wanted to have a demo of it all working, and I can actually log in with Ubuntu One and create a user and do all of that sort of stuff. But sharing that user across multiple services is just not happening at the moment. So yeah, I've been Tony Breeds. I'd like to say thank you to the OpenInfra Foundation and the OpenDev team for helping me get this going. Red Hat, because they're my corporate overlord. And they support my community work, even when it's not necessarily on the product roadmap. SCaLE for accepting my talk. And, oh, Valencia College. I forgot to mention this in there. I even had it on my speaker notes, and I forgot it. Part of the research around possible solutions and stuff, we got a couple of university partnership program students, and they helped me do essentially a literature review, like what various identity providers there are, which services they can read from, which protocols they can speak out, and all that sort of stuff. And they did a lot to help me go down the Keycloak and writing a social plugin. So yeah, now we've got roughly 5 minutes for questions, if there are any. Sure.
So your social plugin that you wrote over Christmas break, that kind of like translates from people logging through Ubuntu One to Keycloak to log into the service? Is there some sort of translation?
Yeah, so the question was, the social plugin I wrote, does it effectively translate between the Ubuntu One and a Keycloak user? And then, yeah, that's what it does. So when I didn't bring up the VPN. I can give you a demo afterwards. But yeah, so I say log into Keycloak with Ubuntu One. That redirects me to Ubuntu One, and I can log in there, or if I'm already logged in there, I can say, yes, I'm prepared to share this information with that Keycloak service. And then that information goes back to Keycloak. Keycloak creates a user based on the information that Ubuntu One gives it. And then I can, from that point on, I can log into Keycloak as that user. So, yeah. Does that answer your question?
Yeah.
Perfect. Anybody else? Sure.
So what were those ones, or
Those students have graduated. I'd be happy to take on some more. Turns out I'm not a super good mentor when I don't have a solid end game. So the literature review was really helpful, and now that I've got maybe a dozen bugs that I need to fix, having some more people to help code would actually be good. So I should go find Corey. Yeah. That sounds good. Anyone else? Nope. Cool. Well, thank you all for attending. I hope it was moderately interesting. Hopefully, I haven't burned my bridges and I can come and give you another talk in a few months' time and show you it actually working. That might be a lightning talk, though.
Woohoo! Thank you so much, Tony. Thank you, everyone, for coming out today. And we have concluded all our talks for Room 107. Just to give you guys a little bit of background, tomorrow we will not be in Room 107. This room will not be for speaker presentations. However, we will be back to our regular scheduled program on Friday. So stop by Room 107 Friday. So anyway, thank you all. Bye.
was trying to see. Baby, let's start going. How does my voice sound? Good. No, it's with you. It's with you. Okay.